So,
How are
dear
you?
participants, yeah, I'm good, sir.
Yeah,
And
okay.
happy to have you here as one of our speaker for the session.
Okay, thank you. No problem.
So, good evening, participants. We welcome you for another enriching, informative session. So, it gives me immense pleasure to introduce our distinguished guest speaker, Mr. Vijay Anand Senniappan, Senior Technology Architect at Infosys Limited, Chennai. So, Mr. Vijay is a highly accomplished technology leader with over 2 decades of experience in architecting, designing, and leading the development of large-scale enterprise platforms and applications. His expertise spans around .NET technologies, cloud architecture, and emerging AI and ML solutions, making him a true innovator in the digital transformation space. So throughout his remarkable career, he has worked with several global clients, including Microsoft, Dell, PepsiCo, Bank of America, and Heineken. So delivering impactful, scalable, and secure solutions across industries such as high-tech, retail, and financial services. So notably, Mr. Vijay played a pivotal role in architecting Heineken's global B2B e-commerce platform, which is now successfully deployed across 26 plus international markets, streamlining operations, loyalty programs, and promotions. So beyond his technical expertise, he is also a mentor and thought leader, driving excellence in architecture modernization, developing optimization automation, AI adoption, and performance optimization within enterprise system. With a strong passion for innovation, Mr. Vijay continues to explore generative AI, LLM-based solutions, and agentic AI to enhance business operations and customer experiences. So we are truly honored to have him with us today to share his insights on cloud architecture and AI-driven expertise solutions. So please join me in extending a very warm welcome to Mr. Vijay Anand Senniappan from Infosys Limited. So we welcome you, sir.
Welcome you, sir. Yes.
Thank you. Hey, thank you, Anu ma'am, for a very nice introduction. You saved my time today. Thank you so much.
Over to you, sir.
Can we get started or you want to wait for some more time?
No, sir. You can start, sir.
Okay. So I will share my screen. Okay. And okay, so I'm sharing. Okay. Is my screen visible to you?
Yeah, sir. Your screen is visible, sir.
Just give me one second. Okay, I'm switching off my video and for some time.
Sure, sir. Sure,
Until
sir.
I complete the presentation. Okay.
Sure, sure.
Okay. Thanks everyone for joining today and spending your wonderful evening time with us. And so, as Anu said, I'm Vijayanand from Infosys. I'm Senior Technology Architect and I'm based out of Chennai. And today we are going to see the topic modeling using LDA. Okay, let's see and what is topic modeling, right? And how it works. And topic modeling is the one of the unsupervised machine learning model. So when you see the all the machine learning models, majorly it will fall into two type of learning models, right? Supervised machine learning model and unsupervised machine learning model. When you talk about supervised machine learning model, where we teach or train the machine learning model with a known data or labeled data. For example, if you want the machine learning model to detect the pictures of the dog, you will train the model with various type of dog pictures, right? And different colors of the dog, black color dog and white color and brown color, and different breeds of the dog, right? Alsatian and Labrador dog, and the dog who is eating, sleeping, and playing, right? So you will feed in all type of different dog pictures to the machine so that machine will learn on its own, right? And then when you give a new picture of the dog, then it will be easily understand and tell that, okay, this is a picture of the dog, right? That is called supervised learning where you are training a model with a known data under your supervision, right? When you talk about unsupervised learning, when we don't know, when we have a unknown data, right? When we have a data and we don't know what is underlying information for those data, and also unstructured data or unlabeled data, right? You can call it in any terms. So when you have unknown data, and so you want the machine learning model to understand and find the information you are looking for. So the topic modeling is one of the unsupervised machine learning model, right? And what it does, so it will find when you have a large corpus or large volume of the text documents or text data and unstructured data, and the topic model will help you to find the hidden themes or interesting informations cooking underneath the documents, right? And it will identify and tell it to you, right? That is what the topic modeling is all about. And so it works on the intuition that if you look at any text document or text data, and the intuition is that each document will have one or more topics, right? And each topic will have more number of words. Okay, this is the intuition, something like the book has many chapters and chapter has many words, right? So this is the intuition behind and how the topic model works, correct? So each document will have more than one topics or one or more topics, and topic will have more number of words, right? When we have a large volume of data, so all you have is the document and the words, right? So topic model will slightly work in a backtracking mode, okay? And it will find the words which are frequently coming together, right? And the words which are co-occurring together, right? And then it will try to put those words into the same topic, right? So it will backtrack, it will find out the words which are coming together or giving similar meaning. It will try to put them into the same topic. In this way, it will find the topics that are there in the each document, right? So this is the intuition, and this is the high level logic the topic modeling works, all the topic modelers, right? So with this understanding, and we'll see where and all the topic modelings are used in a real world scenarios, right? Some of the real world scenarios or use cases I have given here. It's not limited to only this, and if you have any specific requirements in the application you are analyzing or checking, and you can have your own data also, right? But these are the broader categories where the topic modeling is becoming very useful and handy, right? And the customer feedback, right? And the product reviews, right? Especially in the e-commerce platform, the people are buying the product and giving the review. And there are survey responses, right? In the any organization, any educational institution, you are getting the survey. Even in the government organization initiatives also, we're getting a lot of survey responses, right? And any application, any products, people will be reaching out to customer support desk and creating a lot of customer support tickets to investigate and resolve the problem, right? And any social media comments or the posts, right? These are the typical customer feedback data. So we don't know what this data is all about, right? And if there is social media, what is the current trend of topic going, or current topic is currently going on? And if it is a support ticket, what is the recent issues and which product is having more number of issues, right? And product reviews also, right? Which product is good and affordable and so on. So the topic model will come handy here to find the topics that are being talked about in this data, right? And then similarly for recommendation, right? And it will aid the search, right? And instead of doing text search, and it will find the high level topics, and then that will help in the recommendation system, right? The recommendation is like any product you are buying, and it will give a recommendations. Any course the people are taking, then it will give a recommended courses, right? So it will help in the recommendation system also. And market analysis is one of the area, and there are a lot of data available for the competitors and sentiment of the people, right? And the industry trends. So the large data is available, and you have to find out the interesting topics so that you can do better marketing for your own product, right? And similarly for academic and summarization, When you have a large document and without reading the document, you wanted to know, right? And what are the important informations or high level details, right? And that summarization use case also, we can use topic modeling and also document organization, right? Huge number of documents, you wanted to group the documents into each category, then topic modeling will be useful, right? This is not limited to these use cases, but these are the broader use cases where we can use the topic modeling. Okay. Hope I'm audible and clear.
Yes, sir.
Okay, good. Thank you. So it's little theoretical. Before I give the demo, I wanted to give some context. That's the reason I'm talking from the theoretical aspects. So topic modeling, and there are various topic modeling techniques available, and these are the commonly used topic model techniques. Okay, LDA is one of them, and LDA stands for latent direct allocation. And there is a guided LDA, and there is a NMF, and there is a BERT topic, right? And each one has its own pros and cons, and depends on the situation and depends on your own requirement and the data that you are analyzing and the information you wanted to retrieve. And you can choose one of these topic models, right? And LDA is a very common and general purpose model, and it's lightweight model as well. And BERT topic is a very modern one by using the transformer and architecture and clustering, and use LLMs also to some extent, correct? And for LDA, it's a traditional models which works based on the probabilistic techniques, and it is used. It's there for quite some time. I think it's since 2007. It's there. It's broadly used, and it's easily interpretable, and it works well with a large corpus of data. Okay. And it may struggle for the short text, right? And very small, the document or the data has very less number of words, then it may struggle to find the topic. But when you have a large corpus, it will work well, right? And since it is working based on the word co-occurrence, okay, so some level of word context it won't be able to do like a word topic or LLMs, right? So there is a limitation for LDA. And moreover, it will find the topic, and it will, each topic, it will give the words that are falling into the topic, but it will not be labeling the topic. Okay, so you have to infer from the words that are presented for each topic, then you have to come up with a labeling of the topic, right? That is same for guided LDA and the NMF as well. And per topic, since it's advanced, it will be able to tell the topic name as well, right? And guided LDA is another variation of LDA. It's LDA, but it's another variation where when you have a good domain handle or domain knowledge of the applications or any data set that you're working on, and you can tell, okay, these are the possible topics, and each topic, and these are the possible words that may come under, right? So you can see that information to the LDA. So LDA will try to converge the documents or converge the topics into any of the topics that you have already given as a feed, right? So that is that will become very helpful when you have good domain knowledge, and also the data that you are analyzing, right? And you have some good understanding of the data, then you can go for a guided LDA. So NMF is another variation, another mathematical model. It's based on a linear algebra model and matrix factorization technique it will use. And so it will improve the coherence of the topic, meaning, and the words that are coming into the topic, right? And it will be more coherent, right? And it will be more similar, or the similarity between the words will be better for the NMF model, but the interpretation will have some challenges, right? And BERT is the modern technique, and that it will use transformer architecture, which is used in our LLMs like a chatbot, Gemini, and all. And it will use clustering, right? And it will work well, and it will be, because of the architecture in nature, complex architecture in nature, the computational power will be more, right? And so you have to choose this when you have high quality data or complex data, right? And where you want to have high accuracy, and you can still afford to spend more money, then you can go for a BERT topic, right? And today we plan to cover some part of both topic, but we'll see. But the focus is for LD. So any questions so far before we dig deeper into LDA? Okay. Since I'm in the presentation mode, if there are any questions in the chat, I won't be able to see it. And so probably you can speak up. Okay. Hope everything is clear. Then let me move on to the next part. So this is another viewpoint and how the LDA works, right? And you have a collection of documents. So you have a collection of documents, and the documents, when you feed that documents into the LDA algorithm, and the LDA will find one or more topics within the document. And here, if you have 3 documents, the document 1 has 3 topics, and document 2 has only 1 topic, and document 3 has 2 topics, right? And put together 3 topics. Okay. So we'll see how LDA works. Okay, so it's very high level information. You are having a documents, and the LDA will convert the documents into the topics and topics into the words. So how the LDA works? Okay, so for any Word document, right? Any Word document in a vector space, you can represent it as a document term matrix. Okay, so the document has a words, and this can be represented as in the matrix format. So it's called document term matrix. And assuming you have a 4-word document, and there are some 5 words, and some document has 4 words, some document had all 5 words, right? So this can be represented as a document term matrix. So LDA using probabilistic technique, okay, it will reduce the dimensionality of the matrix. In turn, it will create a 2 low dimensional matrix. Okay, it's a document topic matrix and a topic word matrix. The first matrix M2, it will tell each document what are the topics there. So assuming that the topic, I mean, all 4 documents we have identified 3 topics. So it will have a each document, what are the topics are there, right? And similarly, the topic word matrix and each topic and what are the words there and how many times the word has occurred. Okay, so the objective for LDA is to convert this document matrix. This is what we have, right? Document words. So you wanted to find the document topic matrix and the topic word matrix, right? And the LDA does that. Okay, and so it will randomly do this distribution. Okay, and then it will improve over the period of time by doing the sample iterations. Okay, so at this point in time, and just assume that there is a document term matrix, and LDA will be converting into document topic matrix and the topic word matrix. Okay, so how it is doing? Okay, so it uses first initially it will do the random assignment. Okay, for each word in the document, it will randomly assign to different topics, correct? And each word it will assign to 1 topic, right? And randomly it will do the assignment first, and that the random assignments will not be accurate, right? We know that. So random is not accurate solution, and but in to start with, we'll do the random assignment. Okay, and LDA uses sampling technique called Gibbs sampling, right? And by using the Gibbs sampling, it will reassign the word to the topic. Okay, how it will reassign the topic? I mean, how it will reassign that word to the topic by using probabilistic technique. Okay, and there are 2 probabilities, P1 and P2. So first probability will tell so how common the topic in the document. Okay, the topic, the document have 1 or 2 topics, right? And how common that topic in the document, right? So probably um, um, the document will talk about sports majorly, and also it will talk about safety, right? Very minimal. So, but the sports is the major topic in the document, correct? So the P1 probability will tell how common that topic in the document T. There is a P2, how common the word in the topic T. Okay, so if the goal appears in the sports topic, even though it appears in the different document, most likely it will fall into sports, right? And how common the word in that particular topic. So that will give the P2 will give that probability. So multiplied, I mean, we have the product of P1 and P2 will give an overall probability of the word for that particular topic. Okay. And then it will based on the probability and which topic is having more probability for that word, then the topic is assigned to that particular topic. Okay, this process will be repeated until it converges, right? After some point in some iterations, the assignment will be very minimal or there are no reassignment happens. So in that state, it is a convergent state. Okay, so we'll look into that with a small example. So assume there are two documents, right? One document is having apple, banana, apple. Okay, and document 2 is having car, engine, car. So the first document talks about fruits and second document talks about automobile, right? So assume that there are two topics, right? Here, just looking at the word, and we will be able to understand there are only two topics, topic A and B. And the vocabulary is only 4 words, right? Apple, banana, car, and engine. Okay, so then initially we will do the random assignment. Okay, we'll take a word apple in the document 1 assigned to topic A. And the second word will assign to topic B. And third word also apple and assigned to topic A. Similarly, car is topic B and engine is the car topic A and the car is B. This is a random assignment you have seen, right? I mean, there is no intelligence required here and randomly we will assign the word into each topic. Okay, this is a random assignment, but this is not accurate, right? It's not going to give a right information to us. So then we have to iterate by using Gibbs sampling and see how the topics are getting reassigned. Okay, let's look at the word banana at the position 2 in the document 1. Okay, so we'll find the probability for topic A. So there is a probability 0.5, right? I'm not doing the calculation, mathematical calculation here for the interest of our time. But if you go with this, right, and okay, if you go with this one, P1 and P2, and there is a formula available. So for the banana 2, and probability for the P topic A is 0.083 and topic B is 0.041, right? And the topic A has more probability. The banana word will be reassigned to topic A. Okay, like this. Similarly, for all the words we do it. So this is one iteration, and for car also. And if you look at engine, right, then based on the probability, it may reassign to topic B. Okay, and so since it's a very small corpus with a very few words, but the large document with large words vocabulary, it requires a lot of iterations, okay, to converge. Right? And apart from this probability, there are some hyperparameters in the model, like alpha and beta. This is majorly used for avoid the zero probability, right? So if the document is not present, then probability will become 0. To avoid that 0 probability, the alpha beta are used, right? And the probability formula will include alpha and beta. And vocabulary also is used in that formula. And the alpha, I mean, for this calculation, we have used alpha 1 and beta 1 to avoid the 0 probability. For that, the alpha will decide or will um, um, will decide how many topics each document can have, right? I mean, so if you have a higher value for alpha, the document may be having more topics, right? And the beta is for words per document. The higher the value is beta, the more words will be present in topic. Okay, so by adjusting this parameter, then we can get into the good state, final state of the model. Okay, so we'll see that in a demo and how this is used. And if you have a lesser value, that less number of topics will be identified in the document. And if you have a less value or more value for the beta, and more words will be identified for the topic. So these are the parameters, hyperparameters that can be used and fine-tuned at the time of executing the model. So any questions here? I mean, this is very high level viewpoint, right? How the LDA works, without getting into too much mathematical. And there are two probabilities that are used to find the um, right topic or near close topic for each word. Right? It will not happen in one iteration. The multiple iterations, it will be getting into the convergence step. Any questions here? Okay.
Sir, I just want to understand. You're talking about documents and then the words. Little abstract here. Is it like clustering the secondary data into buckets? Something, are we trying to do that? Is
No,
it
clustering is
clustering?
yeah, something similar, but the clustering is that each document will be going into one cluster, right? So here in this case, we wanted to find out more topics in the same document. First, we have to find the topics. Clustering is more like you will identify the document and you will find that you will assign the document into the respective cluster, right? But whereas the document may have more than one document. So the same example I have told, right? And the document will have sports majorly and safety aspects very less, right? But this document will be in the clustering technique, it will be moved into cluster, sports cluster. But it has a topic for health aspect also or safety aspect also, right? So the clustering will not be able to find that. Whereas in the topic modeling, the document will have more than one topics and it will be able to find out. It's more like a close to clustering, but it's more than clustering to identify more topics in the same document.
Sir, we're trying to get some idea, but the real-time application of this technique is hello.
Yeah.
Yeah. Okay, sir. Somewhere on the real-time application, if you could throw some light on that.
Yes, sir. If we could get some hands-on on this topic, we may understand more rather than having this. Yeah, I understand that this theory is essential, but if we have some hands-on, it would be much more easier for us to understand how this works and what would be the output and what is the difference between this and clustering and things. Thank you, sir.
Yeah. So we have a demo. We'll go through that.
Yeah, thank you. Thank you, sir.
Okay. So
Sir,
this
if
is
you have a content, you can go ahead. Or any process you want to talk.
no, I will cover
Sir,
this.
can you hear me, sir?
Yes. Yes, Murli. Am I audible?
Yes,
Hello.
Yes, sir.
Okay. So I will cover this overall process, then we'll get into the demo. And okay. So for LDA to work, right, and we have a data, and then you have to load the data, load the clean data, right? I mean, whatever the data we are getting, and there is some kind of a cleanup required and encoding and so on. Once we have the cleanup data, and there is a pre-process step is required very much. And this will help us to give only the essential information going into the models. right? And there will be a lot of noise there in the data, and the pre-process will help us to reduce the noise, right? Some of the steps that I have given, but it's not limited to only these steps. Depends on the data set, right? The initial analysis you have to do, and then find out what are the noises you have to remove, right? And the tokenization is the basic technique, and it will split the document into multiple words. And removing the stop words in English, there's a lot of stop words which are having less meaning, like a, they, is, was, and so on, right? There are a lot of stop words, and then we'll remove the stop words. And some cases, right, and the n-grams are required, and the two words can be asked as a one token, right? And for example, the machine learning or lack of knowledge, right? So in those cases, then we can use n-grams, and it depends on your data set, right? And not need for all the data set. And lemmatization that we do, and we convert the word into the root word, like a thinking is word, right? And then the root word will be think, right? So the lemmatization will help to convert the word into its root word, so that we will have a unique set of words. And then we'll create a dictionary, and dictionary is like a vocabulary, right? And all the unique words will be part of the dictionary, and it will be treated as a vocabulary. And then we'll create a corpus. The corpus is something like this, right? Sorry. The document term matrix, right? And how many words are there, and how many times the words occurred in the document. Okay, so once we have done the pre-processing, then we'll create a LDA model. And once the models are created and the output has come, and we'll use some metrics to evaluate whether output is in a right state, right? And then we will use some inter-topic distance metric also. And these are the three metrics we will look into and see whether the parameters that we have given is correct, and the topics and words identified correctly, right? Perplexity is one metric, and the lower the value is better, and the how surprise the model with the new data, right? That is called perplexity. The lower the perplexity is, the better the output is, right? And topic coherence, and the similarity between the words in the same topic is called topic coherence. The higher the coherence is better. Intertopic distance, right? And the overlapping between the topics is, if the overlapping between the topic is less, it is well segregated, I think this is good, right? Then we will see that, okay, so the topics are separated, and it is giving some unique meaning. Okay, so we'll go to the demo, and so I have used news article from the Gaggle and ABC, Australian ABC news channels data for last 10 years. Then we have taken, then I have used it for demo, and I am using Colab today, and I copied, since connect to the Colab Gaggle data directly from the Colab requires some user and user ID and password and key and so on. So I downloaded, and I uploaded directly into the Colab. Okay. So with that, I will show the demo. Let me see what data. Okay, I think I have done some modification. That's okay.
Yeah, you can explain the data, sir, first. What is the data it is, and then you can. Listen.
Okay. So the data is if you look at
You can show the raw data first, and
Okay.
then you can go for the collapse.
Okay, sure.
Participants, you can be hands-on from now on. When Mr. Vijayanand would have been completing his demo, you can also do the demo today. And I myself also, we can show that.
Okay, this is the ABC News data that I'm using it for demo today. There is one more data set I have also downloaded, then we can use it for hands-on. Since it's a large data, it's taking time to load. Okay, it has come. It's a news headlines from ABC News. This is a date in which news, right? It's news headlines. Are you able to see that?
Yes, sir.
It's Australian news, right? And news is talking about there is a community news, there's a political news, right? And then council, news about council, right? And news about death, some digital, right? And external affair news as well. So this is how it's a headlines data, and LDA will little bit struggle to work with a short text, but when you have a large text, then it will work well. But we'll see how it will be able to find the topics between them. Okay, it's already cleaned up data. It's not having a lot of noise here. And is that fine, Murli?
Yes, sir. It is fine, sir.
Okay. So let's jump into the Colab. Okay, so I already ran it. Okay, so let me hope you guys are familiar with Colab, right? And Colab is from Google, and you can run the machine learning models. Okay, so to run the LDA, and some libraries are important. So Gensim is an important library for LDA, and this library is giving us to create a LDA models and work with the LDA models. So word cloud. So word cloud will help us to visualizing the data at the document and the overall corpus, right? And so what are the words that are very prominent in the corpus, right? And it will help us to do. And PyLDA vis, right? It's another visualization tool to help us to understand the inter-topic distance that we talked about. Okay, so these are some important libraries that are needed for LDA, and apart from the MATLAB library for plotting, and the Pandas library is for data, right? Data handling and analysis, right? Then we can use Panda. And NLTK library for NLP related operations, right? The tokenization, stemming. Okay, so these are the key libraries that are needed for LDA. And I have installed the libraries, and then I have imported some of the library methods and objects. Okay, so then for cleaning up the data, then this top words and stemming words, right? And that we have downloaded from NLTA. So this step is downloading that. So then we can read the data set, right? By using the Panda. The Panda reads CSV file and it read the, you can give the path. What I have done is that, and I have downloaded from that location, the Gaggle location, and then I have shared that in Google Drive for this course also. And if you click on this, okay, it's taking time to load. So here you can create a folder. Yeah, so I have created the sample data folder, and here you can upload the data. And I have uploaded the data here. Since the runtime got disconnected, it's not showing any data. Okay. So here it shows the data, right? And if you go here, there is a 3 dot here, and then copy the path, and then you can paste it in the dataset path. Okay, so I think this is the path, correct path only. So for your exercise, and you can upload it into this folder, right? If you go to the content, the files location in the cola, and you can create a folder and then upload it here. Okay, so the Panda will read the data set, and the head information will give the initial 4 or 5 rows, right? And what are the data available, right? And the DF shape will tell you how many rows are there. So almost millions of rows are there, and I'm taking only 10,000 rows for demo purpose. And we need only the headline text column. We don't need the published date column. So for the data, we are getting only the headline text. So the data pre-processing, right, and removing the punctuations and removing stop words, lemmatizing words, right, and we created the functions, and by using NLTK library, and there is a toggle Gemini, right? So this is a AI generated a Gemini tool, right? And you can use this to create a code for you. So you don't have to remember the syntax and so on. And if you wanted to perform some steps, and you can use this to create a code for you. Okay. So once you have done the pre-processing, these steps will be doing all the pre-processing, right? And data apply. So after pre-processing, and this is how the data will look, right? The tokenization is done, and lemmatization and stop word removal, everything is done. This is how the data will look like. Okay, so now the data is cleaned up and pre-processed, right? And you need to look at the data, right? And some analyze the data a little bit and see any further cleanup required or not. Okay, so I'm just checking what are the top words in that the 10,000 rows that I have added into the data set, and what are the top words that are available, right? And there is a police is the commonly used word, and these are the words that are used. So you can use the word cloud also and see the prominent words, and you use the bar chart here. So the police may be like it may be a law and order related topic or crime topic or any other topic, right? And Australia is appearing more because it's Australian news. Okay, the council more related to the political news, right? So this is a one data we can look at, one way to look at it. And also I wanted to, since this is the news headlines, and wanted to look at, right, and how many words are there in the each headlines. Okay, so this is a representation. This is again using MATLAB. So there are many more than 3,000 headlines having 5 or 6, right? And 4, 5, 6. These are the common words in the headline, right? And the some headlines data are having no, 1 word, 2 word, and 3 word and all, right? So probably these data may not be very much useful, and this is also not very much useful, right? Then these are the prominent data that we need to use it, right? Because many rows are having 5 or more words in the headline. Okay, so I did some data little bit cleanup after we did some exploration. And I am taking the headlines which are more than 3 words, okay, and less than 3 words probably may not be giving any meaning or topic. Okay, so after removal, right, then you will be seeing only 3-word headlines here. So now we are building the model, and then we have to create a dictionary. And so here I did some more filtering, and like any document, any word that is appearing less than 5 documents, I am ignoring it. And some words that are appearing in almost all the document, right, and more than 80%, and I am removing it. But this can be adjusted and in order to get the right results. Okay, so this is a LDA model, and with all the default parameter I have given, but this alpha, beta, right, and these are the important, and the number of passes, right, and we don't want to do infinite times to get into the convergence, and I'm giving some number, and the 20 iterations I'm giving here, and the default value for alpha, beta I'm giving. Okay, so initially we have to give the topics. Right now we don't know how many topics are there, and we will start with some topic and slowly increase it and see and how it is converging and what is the how the performance metrics. If the performance metrics are better, then we will stop it with that topic. Right. For the demo, I have done some multiple iteration and find the number of topics here. But you can start with lower number and slowly increase the metric. I mean, increase the topics and see how the metrics are looking like. And the metrics are good, then probably you can stop with that. Okay, so I ran with that, and for 4 topics, and I printed some 20 words, right? And this is the first topic, and it has these words, right? And the second topic has these words, this number of words, third and fourth, right? And then there is a perplexity and coherence, and we find out the perplexity is low for the given data in the demo number that we have given, and coherence is also better. So then PyLDA Vis, right, this is a visualization tool. So if you look at it, there are 4 topics, and the 4 topics are well separated out, and there is one little overlapping is there, that is fine. And this is a better visualization, right? And if you go to that topic, next topic, right? And here you can see, so what are the common words in this topic? Okay, so it's talking about police, Australian woman, plan found, murder, right? And killed and all, right? It's talking about attack. So based on the words, then we'll infer that this is talking about some the court and report, right? It's talking about some law and order or crime related topics. Right, so this is something we have to infer, and that is why the subject matter expertise is required, or the understanding of the data set is required, right? And based on looking at the words, then we'll infer that okay, this is talking about some law and order or crime related topic. Okay, the next one you can see. So this topic is having words like this, right? It's talking about council and Sydney and market and election and its state, labor, right? It's talking about political topics, right? So this is talking about something politics. The next topic, this one is talking about water, hospital, health, right? And some national and price, right, and commission review. So it is talking about something related to the healthcare. So this is the 4th topic, and it's again there's some crash and government and rise and minister funding, right? It's talking about some finance and industries, right? So it created 4 topics from the 4 topic words, and we are able to at least infer that okay, this topic is talking about a specific subject. Okay, and then there is a word cloud visualization, and this will again, right, for each topic what are the prominent words, right? Same way the different representation. Okay. So the inference will be a little bit challenging here, right? And but when you have larger corpus and some probably the clear cut words will help us to find the topic, correct? So since it's a news article, we are able to infer, but if it is unknown data set and subject matter expertise required there. Okay. So this completes the demo, and I created one more thing. Okay, this exercise I want you guys to do by using the data set called um, research articles. Okay, so this is having the abstract of the research article. Probably I will show the research article. So
Participants can come out with any doubts in between while the demo itself. I can also share you some files. You can do hands-on from now onwards. I think after this demo we can do. Am I right, sir?
yes, yes. So this is research paper articles data. Okay, it is having data and abstract. So abstract is talking about what that paper is all about, right? So this data I have used it here. Sorry. Okay, if you look at it, no, it's the same notebook, but I just changed the data and some cleanup I have done. I mean, this I am not taking. This has only the okay, there is output and all I have removed it, but so this, okay, I will run it. It will take little. Do we have a time to run it? Murali?
Yes, sir.
So do we have a time to run this one?
Yes, sir. You can run it by
Okay, okay.
7:30. We can give them on hands-on. Half an hour they can do hands-on. We can just see that.
Okay, okay. This one, when you're running this command, right, it is giving a lot of warnings. So this statement will suppress the warning. Okay. So there is a run all option, right? Then you can run it and it will run the cell one by one. Okay. So if you look at it, this is the data set that is used. And I will explain it once everything is running, right? So,
Sir, can you please explain using the abstract and titles data set what you showed us?
okay. This Excel sheet, this data.
Yes, sir. Yes, sir.
So this is the research article data set. Okay. So the various research articles that are there, right? And this article is talking about software industry and it's talking about natural language and big data and computer, and it's talking about some different problems, right? And it's again neural network, and this is again neural network, right? So these are various some mathematical topics also there, and some quantum related topics also there. Okay, this X-ray related enrichment, organics. So this majority of the documents are software related, but there are some topics related to atomic. This is like a science topic, right? This is a science topic. Some mathematical topic is also there. Okay, so this is the research article papers on various subjects. Okay, and it's having title and it's each article it has some abstract. So the abstract is having some a good number of characters, so it will help us to find the topics. Okay, is that fine?
Yes, sir. Yes, sir. Sir, for example, on a particular research domain, we have done the initial cleaning and we have developed this sheet, this what you showed, like title and abstracts.
No, this
And
is the input data.
huh,
This is the input data that we will use it for LDA hands-on to come up with the topics.
yes, sir. Yes, sir. So after this means sheet, uh, if possible, you can show us how this sheet can be loaded and developing that LDA in
Yeah, that's
collapse.
what that's what I'm showing it now. So I just ran all, this is the sheet, right? And I just ran all, I think all of them are executed, right? And just before I'm showing that Excel sheet, I just click ran all, so all the comments are executed. It's pretty much same as what we have seen for news article as well. So we have to install all the libraries that are needed. And this is for ignoring the suppressions, right? Suppressing the warning statements. And these are the libraries and import statement that we have to use for all the libraries that are needed. And again, punctuations. So loading the data sets. So we load the data set and the data set head command will display the top 5 rows in the data. Okay, so we don't need the title and we need the abstract alone because we are using the abstract alone to do the topic modeling. Okay, so I'm getting the abstract data alone, and then we are doing all the pre-processing, punctuation, remove all of them. And if you look at the pre-processing steps, and we are removing the punctuation and tokenizing we are doing, and we are removing the stop words. And this document, and in the news document, we don't have any numbers, right? But this document has numbers and some of the special characters, which are not really required for topic modeling, right? And we are not going to do the topic modeling based on the numbers and so on. So those are less significant. So I removed the numbers, especially for this data set. Okay. And so then after the pre-processing, we are showing the top 5 data, right? This is how it's been tokenized. So the data exploratory again, and if you look at this, no, the model is prominent in the entire data set. And then there is a method, data, result, network, and problem, algorithm, paper, approach. Right, so these are I think majority of the papers are on machine learning, it seems. Okay, that's why the top words are all of them, most of them are related to machine learning. Right, and then we have taken the word length, right? And what is the length of abstract text? Right, so I think majority of that abstract text is more than 300 words, so which is good. And so I am removing any abstract which is less than 10 characters or 10 words. I am removing it. And because if the abstract has only 10 words, then it does not give any meaningful information. So I am removing it. And again, creating the dictionary, and I am filtering, no, I mean, any words that are appearing less than 5 documents, I am removing it. Any word that is appearing more than 80% of the document, I am removing it. Then I'm creating the bag of words, the corpus. And here I'm giving, I initially started with 2 and then I slowly increased it and I got into 5. And this parameter only you can change it for at least demonstration. And if you're still not getting the results, you can still change the alpha and beta. Okay, but I did change this. I'm able to get some inference. Okay, so we got 5 topics, and the topic one is talking about the quantum magnetic transition structure and so on. It's more related to the science topic. Astronaut science looks like. And this one is more like a machine learning model learning algorithm performance, right? So the machine learning models. This is something like a user controlled study. So some research environmental study control system related topic, it seems. And this is topic about energy, temperatures, and particles spectrum. Again, it's a science topic. Surface measurement, right? And it's more like a energy related topics. And fifth one is like a problem, result, space, numbers. It's a mathematical graph conditions, right? It's more like a mathematical topic, right? So at least 5 topics that emerges. And so again, we calculated this, right? This perplexity score is low and this coherence score is better. And the visualization is also done, right? And if you look at the first topic, so these are the common words for the topic. No, these are mostly on model, method. It's a machine learning one, right? And next topic, function, problem, space, graph, and all, right? This is the mathematical one, right? And the next topic is like a system again, user control, environmental. It's more like a control environmental science, right? Control system and environmental science related. And fourth one is it's like energy, particles, spectrum, again science. Okay. So this is how we are able to find some topics. Since it has a large corpus, it's able, at least we are able to infer into some topics, right? And but in news we have some difficulties because of the less text, right? But it has more text, we're able to infer something. So here also, if you look at this inter-topic distance is also better here. If you see more overlapping, then which means that you have to reduce the topic or you have to increase the iterations. Okay, so when you do this modeling rate, the topic probably you can start with low number and slowly increase, and you can keep alpha, beta, auto, and probably iteration you can increase. Iterations, right? The passes you can increase and see whether it is converging. So for every pass, right, you can check the score, perplexity score and coherence score, and also that inter-topic distance.
Shall we look into the research perspective, sir, if you have completed it?
Yes. I'm done actually.
I think Mr. Venugopal is also here with you, I hope so. Is it right? Good evening.
Yeah, even.
Yeah. Good evening, all.
Yeah. Okay. Vijayanand, sir, you can just come in a video so that we'll have a small screenshot as for
Okay,
the
sure.
purpose. We will put it.
Can I stop the share?
Yeah. No. You keep the sharing and keep your video on. Just for a moment, I will just put a screenshot.
Okay. Since I'm scanning mode, I won't be able to see this. Okay. So
No,
is it visible
that is
now?
not an issue, sir. Just a minute.
Okay.
1 minute.
So Venu, you want to add any additional points?
I think you have covered everything.
Actually,
I just
whatever
added
you
few
have covered-
points in the chat.
Okay, good. Thank you.
We saw that also. Is correct. Venugopal has told about some of the libraries, BERT library, which can be used, and what faculty would be very helpful is how this can be made into the research. That is what it is very important for them. Okay, so in that aspect, I will cover for the next 10 minutes, so that you also can please stay here and you can also look how it is there in the research, and you can just clarify the doubts. Let me complete it in some 10 minutes. Yeah.
Sure.
Just a minute, sir. I will just start sharing my screen.
So one doubt from my side. Shall I
Yeah.
clarify, sir?
Yeah. Please, Vijayanand, sir, please.
Yes, please.
Sir, how do we extract this kind of data, a high corpus data from any database, or from where we can extract this kind of data, sir? For doing this topic modeling?
No, generally, I have used some sample data that are available in the Gaggle, and for real world your cases, right? Then you will be having data, right? And suppose somebody is asking you, for academic purpose, there are a lot of sample data available in the Gaggle and GitHub, right? That we can directly download it. Some of the links also I have given. The Gaggle is the one source where you can see all kind of sample data for academic purpose. Okay, but real world use cases, typically the data will be given by the customer, right? And the people who want us to do the topic modeling for their own data. So the data will be given by them, right? And the data may reside in maybe the flat files, or it may be in database, right? And then we will extract the data into flat files, and then we can start doing the processing, right? For academic purpose, a lot of data available in the Google.
Let me also give an answer for this. Let me also give answer for this by adding a value to the Vijayanand's. I think Professor Teresa, you have raised this question, right? Yeah.
Yes, sir. Yes, sir.
Actually, madam, how we academic people will do is, that is what I'm going to cover now. You can use that. I will also share the codes with how Pro Vijayanand has explained you. So where we can get the data is Twitter is one source of taking all those data. For example, let me tell you, last Diwali, I think, Ola has a massive offer. Hope you can remember. Massive offer, and they provided bikes for the rate of 65,000, I think so. Okay, and what happened? So many complaints about the bikes were happened, and all the complaints and the people's issues you can see in the Twitter with like Ola complaints. So there are with some popular hashtags as came EV issues. So what happened? There were some more than 1 lakh tweets were there against the Ola. It was happened. What some of the researchers have done is they have collected all these tweets which is related to this uh, hashtags by writing a separate coding. There is a package called Tweepy. This is one of the Python package. You can write this code and you can have a API access with Twitter. Okay, it's a payable. Some of the institutions which is having big data analytics, they already have it. You can use this Tweepy and you can collect all these 1 lakh tweets. All these tweets can be processed into the topic modeling, how Mr. Vijayanand has run it, and types of complaints into so many clusters. If you have 5 topics, yes, showed k is equal to 5. I think 5 types of complaints will be segregated, and you can give this to Ola, stating that this is how your complaints can be issued. So what is the basic logic behind the topic modeling is, it will give you the hidden things. I think I answered your question, Professor Tanser.
Yes, sir. Yes, sir. Thank
Yeah,
you.
fine. So Twitter is one such space, and yeah.
Sir, good evening, sir. Sir, shall we use the downloaded document, that is CSV file from Scopus as well as Web of Science directly?
Yes, madam. I'm just coming for that. May I know who raised this question?
Shiva, sir.
Professor Shiba. Okay. Yeah, Professor Shiba, you can see that you can use the CSV file. This is one new form of doing the research. You can collect the scopus.csv files from Scopus, and you can write a systematic literature review by finding the existing literature available in the Scopus files. You can do with the help of Scopus. You can take from Web of Science. So these are the two platforms which are already available, but both are a paid version. You can see my screen now. Since Professor Shiba has raised this, you can see one of the research paper, which is written
Screen is not
with the help of.
visible, sir. Your screen
Screen is not visible. I'm sorry.
Yeah, okay. We'll stop my share.
Oh, sorry. All this time I was typing something. I think you all were seeing it. Okay, right. Hope now you can see my screen. Yeah, I think I have just shared this paper with all of.
Yes, sir.
I shared this paper with all of you. So this is the HR paper. Transformative Artificial Intelligence in Human Resource Management, Enhance the Work-Class Planning with Topic Modeling. So this is, I think you can view this paper. This is an open source paper only. You can read the paper. Just by looking at the paper itself, you can understand what the paper is supposed to say. Just the paper is getting downloading. You can see here. So what the authors have written. The authors from Amrita, they have written this paper. Okay, just a minute. Yeah, you can see how Venugopal has explained about the bird topic model. These authors also used that, and they have selected some of the Scopus paper, I think, that is related to AI and HRM, and what are the decisions they have taken. That is already told in the abstract itself. you can see they have written two objectives. One is to identify the focus areas of AI application in HRM, and the second one is to find out the organizational change in augmented AI HRM symbiosis. So how they have done is they have studied some of the literature paper and they have tabulated it. One such good practice is tabulating some of the good papers, most cited papers like this table by having the focus area and main findings. And how they have done is they have searched the paper, they did some data screening, they did some eligibility, inclusion, exclusion criteria using Prisma framework, and they have framed two research questions. And after that, they have used all these keywords to download the paper. Can you see here? This is the advanced Scopus query which they have used in the Scopus. Institution which is having a Scopus access, you can copy and paste this in the advanced Boolean operators. So R command alone they have used, and they have yielded 412 papers from the Scopus, out of which they have included 389 papers for the analysis by excluding some of the unwanted papers. So in the topic modeling, they used the BERT topic modeling plan, and the results also they have shared. I don't know whether they have shared the diagrams or the tables or not. Let me see that. If you can read this paper, you can understand. So how can we do this very practically? So let me tell you in a very simple step. So this is one simple LDA code. You can see what are all the libraries which are used. So one is scikit-learn, matplotlib. So if you want workloads, diagrams, matplotlib is one of the important package.
Excuse me, sir. Sorry for interruption.
Yeah.
Sir, you have the same thing like using a CSV file. You just please show us from the step one, like from loading to everything, sir. Then
Yes, madam. That is what I'm doing.
yes, sir. Please.
I'm just first telling you what we are supposed to do. Then I will definitely we will show you, right? Okay. You may see here. So these are all some of the first process. So usually in the abstract there will be a word called the and. So these words will not be useful for processing the topic modeling. So these words will be removed. That is what the first step is called, stop words and pre-processing. So this will remove the common words which will not be included in the topic modeling. Second one is text cleaning. These are all some of the prerequisites for running the topic modeling. And next one is it will convert the text to lowercase. Usually, uppercase letters will not be processed in the topic modeling. It will remove the punctuation. It will remove the numbers. It will remove the unwanted spaces. This is one kind of good data cleaning before proceeding. And the third one is tokenization. That is splits the text into individual words or token for analysis. For example, some words, for example, AI, artificial intelligence. So certain words should be splitted for finding the best results. And next one is lemmatization, stemming. This is reduce the words to the root form. For example, running is actually run. So lemmatization is bringing the actual meaning from the phrased letters. So this will be automatically done when we coded all these things. And finally, all these text will be filtered and LDA will be processed, latent Dirichlet allocation. So topic modeling does, yes, one? Yeah.
Sir, all these, the tokenization is lemmatization, we have to type all
We
these
have to code
codes.
it, madam. We have to code it. In our coding, it is already there. It is already there in some of the steps. You can see here. Stop words, it is there. Filtering only the titles, it is there. It is there. Actually, you no need to worry about it. Since we are giving you the template to you, you can run it directly. Only thing, you need to find out how many topics you want. Here in my area, I just mentioned as LDA model, I just made it as 4. If you want 5, you can give it 5. So this is always changeable. Even I can make it over here. You can change.
So except the number of topics, other things remain same.
Other things remains the same. If you have any error, you can correct it here itself, because there is something called clean error option, explain error option is here. If you click that, Gemini will run the code and it will alter the code according to your request. But something is, you need to understand what is happening here. Simply, we cannot run the coding, right? So that is one thing. After finishing all these things, what topic modeling will do? So there are so many topic modelings. LDA alone is not a topic modeling. LDA is one of the widely used method. There are other models called BERT topic modeling is there. But widely, academic research, we use LDA topic modeling. It will create you the workload, it will assign you the topics, and it will save you the results. And what I do is, usually I will create a confidence score, whether titles are rightly matched in the right cluster. Okay. Imagine it will give you 0.95 as a topic confidence score. It shows that 95% the topic is rightly assigned. So this is how
Means
I
the
used to
titles are rightly assigned, sir.
rightly assigned. Yes, correct. You may see
Okay.
here we have written one code also for that. Assign the topics to each document. I think whether in this, yes,
So this
there is called
confidence score also included in research paper, sir?
it can be written as the line, madam. Not all the topic scores, because for each topic a score will be given. You may see here dominant topic, that is actually the score. So dominant topic, when it is near to one, it is called dominant topic. That is what we call it as topic scores.
Yes.
We have made it.
Shall I,
So for
sir?
the
Ma'am, if you want, you can explain in the methodological part all these things.
sorry, madam.
Sir, as I'm explaining her question, sir. If she wants, she can explain in the methodological part all these things.
Oh, okay,
If
okay.
possible.
Yeah, yes, correct, madam, correct. Now I'm just running this code. You may see here, I just asked her to create a data frame with all the results. And finally, the results would be saved in the CSV format, because we need the results as a CSV, not the output as here. CSV file, we can do some filtration and everything. So we are using upload files. While Vijayanand has run the file, he has written very well the coding with finding the path directly from our system. For your easiness, I have made it a button here to choose the file directly here. So before choosing the file, you just understand our Scopus file. So usually the Scopus downloaded files will look like this. Like how Professor Lim from Malaysia on the day, Sunway Business School, he has explained us how to download a CSV file. That file is already there with all of you. So usually our CSV file looks like this only: authors, title, year, all these things. So what we have written a coding is to read the title and to read the abstract. Only both this column will be taken. So the titles and abstracts will be pre-processed and cluster of topics will be assigned based on this. So what I'm going to do is I'm just going to run the file. So now we are running the file. So this is the file, Scopus file, which you are downloaded. So if it is a big file, it will take some time, but the percentage, it will be going. Topic modeling is ready now. You can see we got 4 topics. Okay, since I have mentioned it as 4 here, we got 4. If we give 5, it will change to 5. What we have to do is, first we should save all these files very carefully. Word cloud. So usually topic modeling starts with 0. So here we took with topic 1. So I'm just giving it as 1. So I'm going for second one. I'm going for third one, and I'm going for fourth one. So how to interpret this is, it's a big logical connections. You should give some logical connections into it. For example, let me open the first one. You can see how this workload is logically connected. You may see the financial area is highly researched, and you can see there is a good relation between this financial and intelligence. Okay, and you can see technology is playing an important role. So from this we can understand topic 1 is highly related with the technology. It is highly related with the AI. It is somewhere it is discussed, some economic concepts were discussed. So topic 1 is all about financial technology or financial intelligence. This is where we can keep a name for this topic. And topic 2 is all about financial modeling, data modeling. Something is about fraud prediction. There is something called blockchain, anomaly deductions are there, where poor customers, bad customers, fraudulent customers can be identified. So somewhere financial related studies are studying about the fraud. So you can say that topic 2 is all about fraud, modeling the fraud analysis. We can take it out. And topic 3 is somewhere it is deduction about banking and AI. So here we talked about financial intelligence. Topic 2, we talked about fraud prediction. Topic 3, we were talking about, very importantly, banking. And topic 4 is all about machine learning in the financial model. So all the four distinct topics. This is where we are supposed to write and discussions based on each clusters or each topic which is assigned. Now the output file were downloaded. You can look at the output file now. If you look at the output file, the clusters were allocated. Okay. Now what I'm going to do is I'm just going to delete all the unwanted areas. One minute. Okay. If you look at the unwanted areas there, I'm just deleting it. And I'm just bringing only the abstract under the title here, so that easily we can read. I'm just taking all the author's name, everything. So you can see there is only 4 columns we have here. Okay. So let me create a filter here. Okay. Let me see topic wise, smallest to largest. How many papers are here? Okay. So you can see dominant topic. So out of 1,444 paper, highest paper were clustered in 3. That is all about banking, I think. So I think topic 3 is about banking. Okay. And we can find out the topic scores. So if you convert this, as a percentage, it will show which topic it has got assigned. Somewhere, if it is related to 2018, in topic 1, this paper is getting assigned. This is where we used to apply a topic modeling. So how to write a paper based on this? You have to select some research gap based on this. From the workload, you can see undermined research area. Then based on these papers, you can take the full paper of all these things or abstracts of all these things. You can write a narrative synthesis. Then you can write some implications or discussions based on this. You can give a research gap. So which area is underutilized?
Sir,
You
can
can give
you
a
see that future research questions can be formulated based on
yes,
this?
yes. Future research questions. I think research questions should be formulated for each cluster you need to do. So if you look at some of the research papers, they have done based on that. Very importantly, I can share you some of the papers also. Even one paper I can show you which is related to that. Systematic literature review. Now it is very common. It is written with the help of the topic modeling. I think I have clarified yours, but we can see one of the paper how they have written. So in the Journal of Financial Crime, they have written a paper about fraud detection. Literature review itself they have written. You can see how they have written, like how I have done, they would have done. But mostly they would not bring these tables inside the paper. You can see here 2 decades of financial statement. For example, for 20 years, they would have taken the data. If you look in the findings or research methodology, you can see from which year to which year. So, and they have written some narrative synthesis. They have cited the right paper. You can see down to et al. This is the Professor Lim's bibliometric paper. He showed us, right? So this is the citation of that paper. So they go framed some 9 research questions, and they applied the topic modeling, and they set some of the parameters, and you can see right from 2001 to 21. So that is where they were saying it as a 20 decades. Sorry, 2 decades. They applied Weaver also, a bibliometric tool. They have made some country-wise mapping. So which country is highly related? You can see United States is highly related with United Kingdom, Taiwan. So these analysis you can do with the help of the bibliometric tools. And they have made the Weaver's author's contribution also. The keyword, like how we made a keyword analysis, they have did that. So they have made the frequency of keyword. And this is where Mr. Vijayanand were explaining you the frequency of keyword. He showed you in diagram. Here they go. Usually in research papers, using of the too many diagrams will annoy the editor in chief, so that they were used the tables. And this is the topic modeling they have used with the number of contributions of the papers. They have made the biggest word cloud here. And they have found out some clusters. See how many clusters they have brought in. So finally, they have discussed all those clusters. And they have made a good thing here. So somebody told that they want this paper. No issues. I can share this paper. Okay, I think I'm done for the day now. You can understand what is actually.
Thank you so much. You have explained very simple way for actually for writing the research paper. But again, sir, I will ask, maybe, I don't know, my question is need to be asked or not. Sir, but like how you run those, like just you go to that Colab window, sir, and how you load it and how you run those codes, sir. You please show us once, sir.
Yeah, again, we can show you. So after this code is ready, I'm just running it. Okay. So once we run it, you don't know whether it is running or not. Only by this rotational thing you can see. If you want to interrupt, you can interrupt. You can go down. It will ask for a choose file. It will be at the down. You don't know whether it is ready or not. Usually you need to scroll down. Then you need to go. You need to choose your file, upload it. Please patiently wait until it's uploaded. So once it is uploaded, the output file will be downloaded, and you can see the download button here. The word clouds and all, it will be displayed at the window,
And
which is kept
moreover,
in the
you
bottom.
can see the executing status also down. So whenever the file is being uploaded, executing status will be shown in the down. Okay.
Yes, exactly.
In Google.
So now you can see all the word clouds are ready here, and you can see the topics are getting downloaded. If it's a big file, it will take some time. Once it has got downloaded, you can see it will be here. And finally, the result page is ready. This is only 10% of our research, and another 90% we need to clean it. Co-authors should read all the topics. You should segregate topics among you people. Each one should write one topic. Then you should read the manuscript. So writing this, doing analysis is easy. Writing is a bit tough. Okay, I think we are close. We can close.
Sir, I have a doubt, sir.
Yes, sir.
So I ran the coding which is given by Vijayanand, sir. So if you allow me to share my screen, I am getting some kind of... Yeah.
Vijayanand, sir, you also can inspect that.
Yeah, sure.
Your name, Professor, you are Teresa. Okay.
Teresa, yes, sir.
Yeah, I'm just making as a co-host, you can share. Since it is related to yours, you can answer.
Sir, I ran this coding. So I could able to get only this loading packages kind of message for every code that I run. So I ran this, I could able to get this output.
You can explain, Professor, what is your doubt, so that Vijayanand can also
Ma'am,
understand.
actually, you have just given 4 lines of code where you are downloading the packages. That's why you have got a message like this.
Okay, ma'am. But for this coding also, the df.head also, I could able to get this output.
Will you
I
please
could
come
not
down,
get.
ma'am?
Yeah.
No, it is showing some deprecated warning of the packages. So
That's
if you go at the top right,
yeah.
there is
So
a
this,
command to
yeah,
suppress
maybe in
the.
the middle I have got I got the output for head of.
Yeah. So if you go to the top of the notebook, right, there is a command we added to suppress these warnings, right? Can you go up? After the package install,
Okay.
can you come down the next one? Yeah, there is the second one, right? The one, yeah. Can you run this one?
Yes, sir. I ran this also. So for
Yeah,
this also I could get
can
the
you run
same.
it again? Yeah. So now you can go and run it and it will not show any warnings. So it will show the actual data.
Oh, okay.
Because some of the libraries are deprecated warnings it's shown. So if you run it now, then it will not show the warnings. Yeah, now it will show the actual output.
Oh, okay. Yes, sir. Yes, sir. So I could get the.
Yes.
Yeah. Thank you, sir. Thank you so much.
Okay, no problem.
I think we have explained you a lot. I think Vijayanand gave a technical touch from the industry side, and we have explored from the academic side, I think. Any doubts is there? Otherwise, we can close the session. Professor Anu?
Yeah, thank you, Vijayanand sir. It was a wonderful, informative session.
Yeah, thank you so much, Anu ma'am, Murali sir, for giving that opportunity to present it.
Thank you.
And you started from scratch. Generally, people from industry, it will be very difficult for them since you work with advanced analysis. So you started from scratch, and our participants, I think all of them understood well. Thank you so much, sir.
Okay.
Today they have understood both the perspective. One from how industry person will teach, and how we can teach from our side, from the academy. I think they have got perspectives. Right. So thank you very much, Vijayanand. Thank you. Venugopal was also there. Thank you very much.
Thank you.
Thank you. Bye-bye. Have a good evening.
Thank you. I think Professor
Vinod
Dr.
sir has
Vinod
joined. Yeah.
joined. Fine. Hello, Dr.
Good
Vinod
evening.
sir.
Yeah, I'm here. Can you hear me?
Yes, sir.
Yeah, sir, we can
audible.
hear. For a while, please come in a video. We'll have a screenshots and everything. Hello,
Yes,
sir. Good evening.
see you.
Good evening.
So good evening, everyone. So it's my privilege to introduce our distinguished guest and speaker, Mr. Vinod Venkateswaran, Senior Industry Principal at Infosys, a global leader in technology, consulting, and engineering services. So Mr. Vinod brings with him over 28 years of extensive experience across technology consulting, engineering management, and operations, consistently driving innovation and delivering business results. Throughout his career, he has established new service lines and P&L models, defined go-to-market strategies, and set up innovation centers that help clients experiment with emerging technologies and create immersive customer experiences. At Infosys, he has successfully led global delivery units with multi-million-dollar revenues, nurtured strong client relationships, and driven operational excellence. So his expertise spans technology strategy, product and innovation management, IoT, cloud and analytics, and connected vehicle technologies. A recognized thought leader, Mr. Vinod has been honored with multiple awards, including Technocrat, Best Thought Leader, and Innovation Excellence at Infosys. He has also published several insightful papers on topics such as AIoT transformation, software-defined vehicles, and the future of digital ecosystems in automotive industry. Mr. Vinod holds an MBA from California State University and recently completed his PhD in Business Administration and Management from Vellore Institute of Technology, Chennai, focusing on mergers and acquisition in the Indian IT industry. We are delighted to have him with us today to share his perspectives on technology strategy, innovation, and engineering excellence.
Awesome.
Please join me in warm welcoming Mr. Vinod Venkateswaran or Dr. Vinod
Warm welcome, sir.
Venkateswaran.
Warm welcome.
Yeah, good evening. Thank you so much, Anu, for that kind and long and very nice introduction. It's always good to hear at 8 o'clock. And it looks like pretty much everyone has been on a call for the last 1.5 hours as well. Yeah.
Yeah, sir. They were
Okay.
engaged with Vijayanand sir only.
Okay. Yeah. I'm not going to be as technical as Vijay Anand was. I'm going to keep it light, but I'm very certain that you will gain some understanding, primarily from an application perspective, right, of how the industry looks at clustering, especially, right? I'm going to share my screen, and if one of you could confirm that you're able to see this, I can then get started.
Yeah, so we are able to see your screen. You're good to go.
Okay. Okay. You are able to see the slideshow mode, right? Just to be sure.
No,
Right?
sir. Could you please put it in slideshow?
Okay, hold on. So I think, yeah, just give me a second again. I'm not used to Zoom. We use Teams at work. So is it okay now?
Yeah, sir.
It is okay, right?
Yeah, it's fine now.
Yeah, just give me 1 second before I start this session. Yeah, give me a second, please. Just so that I set this up well and I'm able to deliver it as per your expectations. Right on. Yeah, so today, over the next hour or so, I'm going to speak about some of the business applications of specifically K-means clustering is the topic that has been given to me, right? When you look at this, right, when you look at clustering, actually, before we get to clustering, there's sort of 3 types of machine learning that most of you would have heard about this, right, from the earlier session, right? There is the supervised learning, then there is the unsupervised learning, and then lastly there is the reinforcement learning, right? Supervised learning is when you're feeding the algorithm, you're teaching the algorithm pretty much that this is an apple, this is an orange, this is how it looks like, right? So that's classification. So you have test data, then you teach the algorithm how the attributes of an apple, and then the algorithm starts recognizing it as an apple, right? It starts to minimize the error and so on. Subsequently, you also have regression. Regression is a simple, linear regression. There's polynomial regression and so on, where you're saying that based on the current trends, what will it be, right? What will it be? So this is supervised learning, right? Unsupervised learning is clustering, right? Where you are not telling the algorithm what is an ideal data set. The algorithm is predicting on its own, right? What would be the outcome of this? Clustering is an example of unsupervised learning. Right? What it does is it's basically trying to figure out relationships in the data set, right? And based on just the input. Reinforcement learning is all about when you are trying to reinforce and trying to minimize the error over and over again, so that there is a goal, then the algorithm starts working towards a goal. So today we'll speak about unsupervised learning, clustering. We will talk about a few examples of it as well, right? Agenda for today. We spoke about clustering. We spoke about we'll speak about where we see clustering. We'll then talk about what a K means, how does it work, some of the strengths and limitations of it. We will spend quite a bit of time on the use cases. There are 3 industry sectors that I have taken: retail, banking, and healthcare. And I will provide examples. And these are real life examples, right? You would see this in your surroundings as well. Then we'll talk a little bit about clusters, and I think Dr. Murali has some live examples for you. And then we'll finally leave with how is AI how is AI impacting this whole scenario, right? So let's talk about clustering. Can one of you sort of give me an example of where do you see clustering around you in our day-to-day lives? And maybe I will open the chat window to see if there is. You can chat, or you can maybe unmute yourself and speak up. Hello? Can you hear me?
Yes, sir, we can hear you.
Yeah. So can someone provide an example of where do you see clustering around you in your everyday life?
In banks, where they classify or group customers based on high net worth and so on.
Awesome. Awesome. During online shopping, can you be a little more specific when you say online shopping? Yeah, sentiment analysis. Very good. Purchase habits. Absolutely. Right. So these are examples of using Flipkart, Amazon. Yep. Flipkart, Amazon, right? Yeah, we spoke about this, right? Where do we see clustering in our everyday lives? We are, one of the places where most of us spend a lot of time is on Netflix and every other OTT, not just Netflix, Amazon or any other Amazon, and then your own lives of mapping research teams and all that, right? So we'll talk a little bit about how this happens, and then get to the underlying foundation of how is it done, right? So let's look at Netflix, right, as an example, right? I don't have anything against Netflix. I watch regularly, so nothing against Netflix, right? So what does it do, right? First and foremost, it is recommending similar shows, right? Amazon does groups for promotions. Now, why is Netflix wanting to do this? Why does Netflix wants to recommend similar shows for its viewers? Think about that, right? Why does? Because there has to be a business impact. Otherwise, Netflix is not a charity organization, so is not Amazon, right? They are not doing their charity. So what is the business reason behind it? The business reason is they do not want, and I think if you're chatting, I can't really see because I'm on a full screen mode, so I'll just keep going ahead with it. The reason why Netflix is continuing to recommend shows is because it saves about $1 billion annually, $1 billion annually, when it has people hooked onto its platform. 80% of the subscribers, I'm looking at some numbers here, right? 80% of viewing activity is based on these recommendations. And it is so true, right? I mean, even for us, when you're doing some online shopping, as someone said earlier, right? You look at it and then there is this pop-up that shows saying that, hey, people like you also bought this. sometimes common sense prevails, sometimes common sense doesn't prevail, right? You go on and you click and you buy something because I mean, Amazon is recommending, right? Or Flipkart or any of these others, right? So these are great examples of how clustering is used to help the user make a decision. And in turn, it has an impact on the business. That is very important, right? So, like I said, if Netflix is making sure that you are still in the platform, that it is saving about $1 billion, like I said. 80% of the viewing activity is based on these recommendations that are being provided by the recommendation engine. Now, how does this work, right? So collaborative filtering and content-based filtering, right? These are the two major types of clustering algorithms that Netflix uses. Of course, it's a lot more complex than that, but I'm trying to simplify this so that you get a sense of what it is, right? You get a sense of what it is and how is it typically used in a business scenario, right? So collaborative filtering is when it is behavioral driven of similar users. Let's say me and another person watch Tamil comedy movies, right? And we watched something, we watched Michael Pantana Kamraj, and then there is another Kamal Hassan, Crazy Mohan movie the other person has watched. The system might start recommending that you haven't seen this. Okay? This is based on user interactions. Now, the second part of it, which is content-based, is it is fairly static in the sense that based on the genre that you like, based on your preferences, based on the kind of movies that you watch, it keeps making recommendations. The recommendations actually go beyond that as well, right? In the case of Netflix, it tells you, hey, you know what, because you watched this, here's another example, so on and so forth. Thankfully, so far, Netflix is not, looking at data from other platforms. But once that also starts happening, you're sort of hooked onto it, right? Importantly, right? When you're, let's say this is on a Friday evening, right? I'm talking about the last bullet here of reduces decision fatigue. You have had a long week and you just want to watch something, correct? You're unsure and you keep browsing on the Netflix platform, right? And when these recommendations start popping up, it reduces decision fatigue on your side. And you just pick one and then you start watching. If not, you go back and you start watching another one of those recommendations, right? So very, very useful for businesses to keep their users on the platform, to engage the users, to make recommendations. And what I gave was just few examples, right? The Netflix recommender systems are fairly complex, and they probably take a lot of data, right? Now let's talk a little bit about what is K-means. So Murli, Anu, are we doing okay in terms of the pace at which we are going?
Yes,
Should I
sir.
slow
Yes,
down?
sir. No issue.
Okay.
It's fine.
All right. Yeah. So K-means, like I said, it operates on unlabeled data, right? So you don't have to have any labeling of the data. You just provide the data and it sort of starts discovering the relationships between the data objects and the inherent structure without any knowledge of what that data is. It is iterative, right? And we'll talk about this in a little bit. I'll show this through an example, right? Through an animation of what I mean by iterative. basically what it does is it forms clusters, and there is a centroid position, which is the central position of each of these clusters. What happens is it starts at a point, and then it sort of keeps iterating through it till it gets to the best possible one, right? Each cluster, like I said, is centroid based, which is essentially the mean of the data points, right? Now, how does this work, right? It works by partitioning the data into clusters based on the proximity to the centroids. What this means is, let's say you have 3 sets of data, then there is a centroid in each of them. Then those 3 becomes your K, right? K is then your 3, and then the centroid is where it is. And then the iterative assignment sort of happens. There are some strengths of this algorithm. There are some limitations of this algorithm. So by the way, I mean, most machine learning algorithms, and this is something that I really found out during my thesis as well, because as Anu was saying, my thesis was on mergers and acquisitions, but it was also about predicting M&A in the Indian IT industry using machine learning algorithms, right? So any machine learning algorithm that you pick, it is best suited for one type of a use case or one type of application. There's always going to be some strengths to the algorithm. There's always going to be some limitations to the algorithm. Now, if you have the time, if you have the money, if you are willing to put in the effort, a combination of these ML algorithms is the best way possible, because then you're sort of addressing the limitations of one by bringing in another one. Right? First, let's look at K-means. What are its strengths and what are some of the limitations of this algorithm? Right? The first one, it is computationally very efficient, actually very, very fast. Even if you have large data sets, you can quickly find this, iterate through it, and so on. It does assume spherical clusters. The impact of outliers is important, is significant here. It is very, very sensitive to the impact of both the outliers and to the initial positioning of the centroid. And both of these you will see when I show you the example, right? These are some of the strengths. Now, in terms of limitations, you also need to specify the K, right? Which is, you start with the 3, you start with 5, you start with 7, whichever way. Right? We spoke about it. It cannot really handle outliers very well. It cannot handle non-numeric data. Right? And if there is multiple dimension data, there are, it sort of starts, it's not one of the best algorithms, right? Of course, there are ways and means by which you address each of this, right? Now, we'll talk about pre-processing and preparing secondary, data sets for clustering. Now, this is true for any machine learning algorithm, right? Not just K-means, not just for clustering. Any of these data sets, any of these algorithms, you need this pre-processing. Now, typically in an enterprise scenario, they just don't do this over and over again. What happens is a pipeline is set up, right? Now, what I mean by a pipeline, think about it almost like an assembly line, right? So you have data sources that are coming in. Now, there could be new data that keeps getting added to this data source. It goes through this pipeline or assembly of data cleansing, data normalization. How do you handle missing values? How do you do feature selections over and over again, right? And each of these stages, you keep refining, right? So that the cleansed data set is both clean as well as it is enriched for clustering, right? So think about it that way, right? This is fairly automated now. It's not like Netflix, someone is actually sitting and doing this clustering every day, right? It is not possible either, correct? Because there is so much data that is getting generated. Every day, like, let's say each of us spend an hour at least, there is 250 hours based on the number of people in this meeting of data that is getting generated. Your behavior is getting generated, right? So it has to be in an automated way. That is where the pre-processing and preparation of the data set really comes in, right? Cleansing is about removing errors, inconsistencies. Normalization, what happens is, let's say you have age as an example, right? Or for that matter, income as a data element that you are using. The income could vary from, let's say, 50,000 to 5 lakhs, right? And you want to sort of scale it and normalize it to a, let's say 0 to 1 or any of the other ways, right? So that this data set is not skewing. It is actually not unlikely. It is likely. It is very likely, especially in consumer scenarios, B2C scenarios, that you are always going to find missing values, right? A very, very simple example of a missing value is, rating, user rating, right? Not every one of us clicks on a star rating every time we use a service, right? So that is a missing value. Now, how do you handle that? Multiple ways to handle that. You either ignore the data set or you assume based on some other techniques and so on. Now, what are the features that you would build based on this, right? Why do you have to do this? That's where all of this really comes in, right? Where there are inconsistencies in data. I gave examples of the salary data, right? Outliers really can mess this up, right? Outliers can really mess this up, mess up the algorithm itself. There could be bias in the data as well, right? Now, an example of bias could be either a gender-based bias or a region-based bias, right? And now when you start processing this data, you might be making decisions that are not okay, right? You have to know the provenance of the data, which what it means is that is the data provenance part of it, right? Where you understand what's the origin of the data. And let's say you are combining data, creating a data set from multiple different sources. You really know that one of the data source is not as robust in terms of its quality, then you would have more stringent data cleansing techniques applied onto that data source. Right? So you have to, the data processing, preparing it is absolutely essential for any machine learning algorithm, and so much so, right? For clustering as well. So what I'm going to do is, I thought I had this in one of these. Oh, there it is. I'm going to show an example here. This is a simple animation of how this works now that we have this, right? So these are the data sets, right? It could be a combination of buying behavior, for instance, right? It could be buying behavior, it could be customer segmentation, could be any of these, right? Let's now look at how these the clustering algorithm itself works. The square boxes that you see are the centroids that are working on. Now, in this particular case, it actually has not done a good job. There's 3 of these that are created, but because of the data set, only 2 of the clusters have a lot of this data. But you also see that these outliers have not been managed well. Right? But let me try and start this again, and let's see if it's able to create at least 3 clusters here, right? So it just keeps going on and on until it finds the most optimal way of creating these clusters, right? So that's how very, very simplistically the clustering algorithm works, okay? I think towards the end of it, we'll also do a real life example of it. But that's the sort of the basis of where we are, right? I'm going to move on to the next section of talking about the business use cases. Do we have? Do I stop and take any questions right now, or do you want me to complete this, whichever way?
So I have a question, sir.
Sure.
So what is the outcome of this clustering? Can we have some kind of prediction for this clustering algorithm?
Yeah. So you can, more than prediction, I think it is not used for prediction as much, right?
Yeah.
But it is used for making informed business decisions, right? Let's take an example right here, right, of customer segmentation, right? RFM is a very, very popular segmentation technique that is used in the retail industry, consumer packaged goods industry, right? Retail and consumer. So it is based on 3 fundamental parameters, right? How recently did the customer make a purchase? How often did the customer make a purchase? And how much money has the customer spent? Now you think about this, right? You think about this. Think about, let's rewind back about 15, 20 years, where the, and think about a scenario of your neighborhood grocery store, correct? A neighborhood grocery store. I mean, for example, we used to purchase from a store called Marthandam Stores, where you would send them the list and they would deliver it, or you go pick it up, and so on and so forth. Now, the proprietor of that store actually runs this algorithm in his head. He will come back, if you've not visited him in 2 months, he will say that, hey, sir, I haven't seen you in a couple of months. What's going on? Right? If you only do it monthly, he will still say that, right? Hey, you're not come in between. He will also know what is your average basket size every month, and he would say, you know what, you seem to be spending more, or you seem to be spending less. Now, what does he do based on that? And he either calls, I mean, I'm talking about 15, 20 years ago when there was no digital, correct? And I'll now talk about digital, of how things have really changed, correct? Now he would say that, sometimes he might offer, door delivery, he might offer something else. He would say that if I go back and tell him, hey, you know what, this seems to have expired, he will, replace it, and so on. Now, fast forward to the current generation, right? To the current generation of where you have quick commerce delivering it to you in 10 minutes. You have Amazons, the likes of Amazons, I should say. You also have physical stores. You have, some of them also do over the phone and all that, correct? Any channel, really, it doesn't matter. In fact, ChatGPT recently has announced that you can do e-commerce through ChatGPT as well. Now, think about the data and what your neighborhood general merchant was doing. Algorithms really have that data. If I have been pretty regular, right? I've been very recent. I've made enough purchases and I've spent enough money. You see this where the R is high, the F is high, and the M is high. I am a champion user of this site. So what should I do? I should reward the customer. If I am launching a new product, send it to this customer, get his or her feedback, provide them, VIP service, right? I mean, Atal Black is an example, right? Atal Black and others. So that is the decision as a business you are doing. You are not doing prediction. But now, because of this, that those champions are the ones whom you are engaged onto your platform. You're not letting them go. These champions are the ones who are also talking about your platform to others, because you're now providing them the best of service. You're providing them new product reviews. You are rewarding them consistently. And they, in turn, obviously are spending money on your platform. Now, let's say you're making frequent purchases, but you're spending money, but you're not being regular. Right? You're not being regular, which is where the R is low. So this is at risk customer. Then you sort of take a different strategy in terms of how do you engage them. And similarly, where someone who's not been very often, new customers, you would sort of nurture them, provide them welcome discount. Essentially, you want to get as many of your customers in the champion category, because that's the most beneficial. Now, clustering as a technique is helping you do this segmentation of your customers and helping you decide what should be your strategy. Correct? It's not doing prediction. There are, of course, other algorithms that can help you predict. So hopefully I answered that question the person asked, right? So this is where you would start seeing emails as well, right? Sometimes you get these emails saying that, hey, you know what, we have not seen you in a platform for some time. Now, all of this I'm saying, once again, I'm saying what your neighborhood person, or I mean, for instance, I have been buying fruits from the neighborhood fruit vendor for nearly 20 years now, right? That person almost knows my taste, depending on the month, all of that, right? So all of this is now digitized, and algorithms is helping you sort of make that decision for the business that is run. Hopefully that sort of help you understand how you would use it. Right? Similarly for loyalty as well, right? Now let's say that is based on purchases. Now for loyalty, you're saying that how engaged is a shopper, right? Now if there is someone who's just spending time but not really buying, and they're just looking at multiple products, I mean, it's like you walk into a mall, you're just doing window shopping, correct? You're not really buying anything. Then is there a way to engage that person? Now, someone who's added things to their cart but never really checked out, is there other ways to engage with them? Right? So all of these, you are clustering. Once you've clustered, you can then start making decisions based on that particular cluster. Right? So those two were examples from the retail. In fact, I don't know if Dr. Murli has this data set. One of the examples that we wanted to do for a real life example was, I understand most of you are faculty members. You can apply the same logic to your students as well, right? There are clusters based on students' attentiveness in class, their attendance, their exam scores, the kind of questions that they are asking. You can again sort of start forming clusters. You can decide on how will you sort of, or how much time you will spend on a fully engaged cluster versus not so engaged cluster. And you might want to really spend more time with the person who, with the cluster that is not. These are the sort of decisions as a business, as an enterprise, as an individual, that clustering really. And if you think about it, if you really think about it, right, patterns is how our brain works. We look at patterns in and around us. I mean, it is just very, very natural. I mean, clusters are a ways of, patternizing. You're creating a cluster based on patterns, right? It is very, very normal for all of us as humans to sort of, let's take a few examples of this. Fraud detection, right? Customer makes small purchases locally during weekdays, then all of a sudden a large transaction happens from a foreign country, and you get a call. These days you get a call, right? Any transaction outside, some of my, at least 2 of my credit cards, they are very, very effective. They send out an SMS, they send out a WhatsApp message. If I don't respond to the WhatsApp message within, I don't even know, like 30 seconds, they make a call. And they keep doing this until there is an affirmative or a negative response from them, right? So this is really over a period of time, these transactions, these anomalous transactions, they mature. Now it is very, very fairly accurate, right? It doesn't happen when I buy tea, but it happens when I buy something large, right? So this is an example. Someone spoke about an example of lending decisions. Once again, earlier, again, I'm saying like 25 years ago, 30 years ago, when you didn't have all of this data, there would be a set of questions that the loan officer would ask you. They would take time, they would go visit your property and so on and so forth, fairly lengthy process, right? Before someone is granted loan. They would even also, they would ask you to come to their office and so on. Today, real time or near real time, I would say, right? That all of your data is available. Accurate lending decisions or increased accuracy of lending decisions, right? Let me put it that way, right? There's still people who obviously game the system. Now, you could also use this for saying that, hey, you know what, I'm a low risk, stable income borrower. My credit rating has been good. I've been paying all my installments and so on and so forth. My credit card balances are, have been paid off, so on, right? So, we know there's a low risk, stable income borrower. There could be others and so on. And you make lending decisions. Now, again, you're not predicting what you're doing. The decision is still a human in the loop making the decision, saying that this is the interest rate that I'm going to provide this person a loan. This is how much I'm going to provide. Do I need a collateral from them or not? And so on and so forth, right? Same goes for customer segmentation as well, right? Where you would, based on, this is again in a banking scenario where based on your assets, the transactions, you can cluster your customers, and based on that cluster, you are again providing services, right? Now, why are you providing these services? You're providing services so that they continue to spend money and continue to invest in your bank and continue to maintain the deposit that you're asking and so on and so forth, right? So high value clients, you can provide personalized wealth management services. For the younger savers, introduce them to a portfolio, so on and so forth, right? Lastly, this is around the healthcare. part of it, right? Healthcare part of it, right? And this is again wonderfully, and you would see this being, in our day-to-day lives, right? So at least in Chennai, for instance, right, I can say this, right, that there are these hospitals where you can walk in the morning, like early morning, get your surgery done, and then walk out, right? Or there are these places where it is a short stay, right? You're just getting your fracture is sort of getting fixed, or some other small surgery that doesn't require. Now, what some of the hospitals have done, have created specific centers for these. They figured this out, that it's better to create facilities for such, for lack of a better word, short-term patients, and have them go to a different facility rather than crowd them in the larger facility where you are attending to longer term patients, right? Where they need more care, right? So this is from a healthcare operations perspective, and it also makes sense, right? Resource management, so on and so forth. How do you manage these resources, right? Now, the same thing is getting applied to personalized medicine. When you look at it, personalized medicine also is by looking at images, by looking at the scans. Now, algorithms can help radiologists, oncologists. Now, this is all getting, extremely, the maturity of this is going really up, right? You must have seen our news articles of people who are being saved by their Apple watches, right? Because the heart rate variation has been has been caught, not predicted, has been caught by the Apple Watch, and then it is alerting the emergency services. So again, a lot of enhancements. Now, these are 3 examples of industries that we have taken. Can be any number, right? Any number. I'll give you, Uber does this, right? Uber does this in terms of clustering, right? Based on time, based on peak season, and so on and so forth. Every business, there is a way and means to segment your customer and take decisions based on that. We'll do a very, very quick example of manual clustering. This is just to give you a sense of it, right? What I have is 6 customers here, and just 6, C1, C2. I provided the age. I've provided the monthly spending. How would you group them? Right? It's a very, very simple scenario, but just to sort of give you the power of what can clustering do. How would you group them? You don't need an algorithm. You don't need anything. You just can look at this and you can say what it is. Maybe I'll look at the chat window also. Okay. How would you sort of group them, right? Like cluster 1, cluster 2, cluster 3, 3 clusters. How would you group them? Consider all the data, both consider age and spending. Yeah, of course it is age and spending, but what would be those clusters is what I'm saying. Who would be in which cluster?
Sir, that would be like C1 and C5 can be grouped based on the age and all the money spending limit.
Super.
And then it is like C2 and C6. So
Yeah.
that's also based on the age and the spending. The
Right.
limit is there. The remaining is obviously the C4 and C3 and C4.
Yeah. Now, what would you do, right? What would you do to this group, right? What are the other insights? Yeah, high, medium, low, right?
Yes,
What are
correct.
the other insights that you can gather out of this? C3 and C4 seem to be spending the most,
Yes, sir.
correct?
Yes,
Now, and rightfully so, they are in their mid 40s, possibly,
their
have
yes, their
a
expenses is
family.
more.
Yeah, have a family. So, there is, these are all hypotheses you're making, right? But absolutely valid hypothesis, right? Yeah, they possibly have a family, so which is why their monthly spending. C6 is retired, of course, right? C2 and C6 are retired. You're right. Consumption is more in the mid age. So you now can, if you're a business, and this is what your data is telling you, right? You would, where do you think you will get the maximum buck for your money? If you spend, let's say you have 100 rupees to spend on advertising, which group, which cluster would you spend this 100 rupees on? Or not just which cluster, how would you split the, cluster two, but not all the 100 rupees also, right? You would spend the a significant portion of your advertising budget on cluster two, right? You want to keep them engaged. You want them to keep spending that 32 to 29. Yeah, you're right. 32 to 29,000 rupees. But if there is a possibility, you would also want to increase that amount. Right? Now you see, this is the kind of decisions as a business this data is telling you. Now imagine adding multiple such data elements to it, right? Now that is age. Now let's say you also have how many people in the household. You can also find out how far away are they, and so on and so forth. All of these data elements improve your decision-making capability. If you're doing clustering for clustering's sake, there's no fun. If you're doing this from an enterprise perspective, you have to have a business decision back to it. Okay? I'm going to spend just a few more minutes on some of the best practices, and then I will sort of hand it over to Dr. Murali and Anu, to do some practical examples. Right? See, we've spoken about this best practices perform. Yeah. Okay. Always do data pre-processing. Right. I mean, I from my personal example, and this is not from an enterprise level, but from my own thesis. If I had just taken the data, financial data that was available, I think I would have made, the ML algorithms that I would have used would have just made very, very wrong predictions, correct? And it is very, very evident, right? Sometimes you look at the data set, doesn't matter how big the data set is, right? And which is where your descriptive analysis and so on, which I'm sure all of you are very, very conversant with, right? All of you are from academia, so you obviously know all of this, right? You look at the descriptive analysis and the various metrics that are out of it, and then all the missing values and everything else sort of starts popping up, and you decide how you want to handle these outliers, missing values, and so on. Right? Choosing optimal number of clusters. There's something called as an elbow method. It's basically nothing really complex, right? Which is how do you determine the K, right? So basically, it's a declining curve. As you keep declining, or as you keep making the clusters, the average value keeps declining, and there is a point in time where incrementally it doesn't make a difference. Keep running the algorithm multiple times until you get the right part of the right centroid, right? And write k-means part of it. Now, the last part of it, I think, is the most important part of it, right? You have to have a sense of your data. Whether you are a business, you are an academician, you are whoever it is, you have to have a sense of data. Based on these results, you have to start looking at the clusters and you have to make your decisions on these clusters. Right? What am I going to do? What is this data telling me? Am I going to change course of action? Am I going to make a am I going to make something else, right? A decision based on it. These are some pitfalls to avoid. Once again, most of this is very, very similar to other ML algorithms that you would have used or used. And that's pretty much it. I mean, that's pretty much it. Okay, there's a couple of other slides that you know. So what does all this mean, right? If you are an enterprise, if you are an individual using clustering, always be sure that you are using it to support your core business objectives. Please do not, this is not, and this is true for machine learning, AI in general, correct? Not because B2C, business to consumer, is different from business to business. You can have use cases in business to consumer segment that is experimental, that is fun, right? In a business to business scenario, these experiments have to, it's only two things. Either they have to save, they have to play on the efficiency angle and you're getting more efficient, or they have to help you bring new revenue. Otherwise, it doesn't really make sense. So make sure your clustering techniques, insights is helping you with your business objectives. Target. Now, especially with all of this, right, and the availability of compute power and so on, you can almost personalize marketing, right? You can also leverage it for risk. Like I said, hybrid clustering combines multiple techniques, and it's not just clustering. You can use multiple machine learning algorithms as well. You can use deep learning integration to improve your clustering itself. Some of this is, if you're using Copilot in, for example, in Excel, that's a good example of how it is starting to make those recommendations, right? Real-time analytics enables dynamic clustering. Although, it does talk about dynamic clustering, there's very few businesses where you really are making real-time decisions, right? Based on immediate. So it's not like a marketing campaign is launched based on what I found out 2 minutes ago, right? A marketing campaign is a very, very planned out campaign, correct? It doesn't happen based on a decision or based on some analytics that happened 2 minutes ago. Anyways, that's pretty much what I had to cover. I really hope, most of you sort of were able to get something from a business perspective, right? As much on the, as much on the use of clustering, right? It is, again, it is across the board, right? It doesn't matter, right? Whether you are in marketing, HR, you can use this. I'll take a pause now. I don't know what Anu has planned for the rest of the time.
Yes, sir.
But, yeah.
We have 2 experiments for them, 2 real case scenarios. So we are going to run that.
Super. Are you going to share your screen?
Yeah, I'm going to share my screen, sir.
Okay.
Yeah, I'm going to share my screen.
I'm going to go off video for some time to drink some water.
Participants, we have, yeah. Sure, sir. So participants, we have already shared you a Google folder link, right? So in that FDP support files, you can see the folder named Murali and Anu. In that, if you go to my folder, okay, name Anu, you can see two Google Colab exercises, okay. So one is on customer segmentation file, okay. So the scenario is, imagine you are a data analyst for an online retail company, okay. So imagine the online retail company is having different products, for example, educational supplies, books, electronics, or any other consumer goods. So being the marketing director, you have a problem now, okay. The problem is we are spending the same amount of money marketing to all our 500 customers, okay. But clearly they are not all equal. Some buy frequently and spend a lot, okay. Others haven't purchased in years. So we need to be smarter about where we invest our marketing budget, okay. So the task here, being a marketing manager, is you have to segment customers based on their purchase behavior so that the company can create targeted marketing campaign, okay. So the data set is a customer database, and we have a marketing firm, okay, an online retail company which sells different products like educational supplies, books, electronics, and consumer goods. So just like Dr. Vinod told, we are going to segment customers. Okay. So here we have to consider data like customer ID, then days since last purchase, that is recency, then total number of purchases, that is frequency, and total amount spent, that is monetary. So we are going for an RFM analysis here. Okay. So I request all of you to paste this code in Google Colab, or you can open the file also, Google Colab file. Okay. So there are two ways. Either you can copy and paste the code, or you can open the file directly in Google Colab. Okay. So I'll just run the code for you, and we'll see how to upload the file. So we have to just run the code. So just like Dr. Murali told, we have to run the code. You can see a play button like icon here, that is a run button in Google Colab. So just press on it. So it will ask you to upload the file now. Okay. See, one browse option has come. So the file is also available in the location. Okay. So you can get the file from the location. The file name will be synthetic_customer_data. So in that we have 500 rows of data. Okay. So we have the customer details. So we are going to segment the customers based on the recency, frequency, and monetary value. So when you run this code and upload the file, you'll get the output down, as well as an Excel file is also downloaded. So first, let's see the output first. Okay. So this is the output. So here you can see that the recency, frequency, and monetary value has been calculated. And you can see few statistics also here, like mean, standard deviation, minimum, okay, and the data distribution, okay. So here we can see that recency_days, the maximum value, frequency value, the monetary value, as well as the average order value, and tenure days. Okay. So all the 500 rows data has been loaded, and the statistics has been done. Okay. So what happens here is we have uploaded a 500 customer data, okay, into Python, and each column represents a key metric, that is recency_days, that is days since the customer's last purchase has been done. Okay. Then we have frequency, which is none other than number of purchases made by each customers. Then we have the monetary value. So monetary value accounts for the total amount spent by the customer. Then we have average order value, that is average order value per customer. Then finally, we have tenure days also. So tenure days accounts to how long they have been a customer, or how long they are loyal to our brand. Okay, so these values are the basic statistics which calculates, and we can see that there is a wide variation across customers. Okay, so when you look at the STD values, that is standard deviation values, we can see that there is a wide variation across customers. Okay, another observation is some customers are very recent. That means recency is equal to 0 days. Okay, while others haven't purchased for years. So we have two different set of customers. Okay, some customers are very loyal and we can see that they have bought our product till yesterday. That means 0 days. Okay. And some customers, they are not much loyal to our brand. Okay. So they have not purchased from us for years. So from this, we can see that spending is highly skewed. Okay. So a few heavy spenders pull up the average. So this confirms segmentation is useful. That is, the customer base is not homogeneous. Okay. So now we can see 5 clusters here, starting from cluster 0. Okay. So when you go for cluster 0, you can see that recency is around approximately, okay, 1126 days. Okay. Frequency is approximately 1.6 and monetary value is approximately 97. Okay. So these are the values for cluster 0. Now moving on to cluster 1, we can see that recency is approximately 309 days. Okay. Frequency is approximately 6.3 days. And monetary value is approximately 580. Okay. Now, moving on to cluster 2, we can see that recency value is approximately 149 days. Frequency value is approximately 11.1 days. And monetary value is approximately 1049. Okay. Now, if you move on to cluster 3, we can see that recency value accounts to 24 days. Frequency value is 39.4 and monetary value is around 6041. Okay. And we have the final cluster where we can see that recency value is around 422 days. Frequency value is around 4.8 and monetary value is around 58. Okay. So each row is equal to one cluster, that is K means group of customers with similar purchasing pattern. Okay. So we can see that the customer behavior, based on the customer behavior, we have clustered these customers. Okay. I hope you are able to see my screen. You're able to see my
Yes,
screen
yes, I
better?
know.
Yeah. Okay. So we can see that in case of cluster 3, okay, when we take recency, they are very recent, that is 24 days. Okay. And when you go for frequency, it is very frequent, which accounts to 39. Then when we go for monetary benefit or monetary value, it is very high speed. Okay. That is around 6041. Okay. So what happens is they are the top customers or most loyal customers to our brand. So we should give more importance to them. Okay. Next cluster is cluster number 2, that is fairly recent. Okay. So if you check on their purchase behavior, it is around 149 days. Okay. Then moving on to frequency, the frequency value is around 11. That means they're frequent. Okay. And when we go on for the monetary value, it is around moderate high speed. That means regular good customers. Okay. Then when we move on to cluster number 1, okay, so they are somewhat recent. That is roughly value is around 309 days. And when we go on to the frequency of this cluster, it is moderate and monetary value is medium spent. Okay. That means declining customers. We can't trust on those customers. Okay. Sometimes they may come to our brand or they may go to our competitor also. Okay. Then moving on to cluster 4, they are old customers. So the recency value is around 422 days and frequency value is few, that is 4. And monetary value is low spend. Okay. That is dormant customers. And finally, we have cluster 0, that is very old customers. When we check the recency value, it is around 1126 days. That is almost inactive, right? Very low spend if you take the monetary value means. So what is the interpretation from this? They are the lost customers. Okay. We should not give much focus to that customers itself. Okay. So this is how you do recency, frequency and monetary with K-means clustering. So with this, you'll have an idea like how you have to, cluster your market. So according to our data set, we have 500 customers, right? And we
Hello,
have
ma'am.
a group. Yeah. Yes, ma'am.
Ma'am, this RFM technique, can we use in HR context also?
HR context, ma'am, it is not that applicable, ma'am, because in this case, we are more, we have to have a more understanding of sales. Okay. If you take this
Okay.
data set itself, we want to analyze customers based on their purchase behavior.
Mhm.
Okay, that's why we
That's
have
why, ma'am, I thought
recency,
to clarify if
frequency,
this
and
technique
monitoring.
can be used
Okay.
or not.
No,
Yeah,
but
yeah.
what do you,
Depends
how do
on
you
the
want to,
context. Yeah.
yeah, how do you want to use it? Maybe if you explain the
Maybe it,
scenario.
yeah. Or
Maybe
I
sir,
can give
in
you a
terms
scenario.
of
When you want to see the employee attrition rate. Okay, you want to see whether,
attrition rate,
yeah.
measuring the attrition rate,
Huh.
that can be done, sir, in this RFM.
No. So it is not RFM, correct? As Anu rightly explained, it is not RFM. But let's say attrition, correct? Now, for a set of employees, you want to know their current tenure with the company, right? Maybe their last appraisal rating, the salary band that they are in, right? If you're capturing their reason for resignation, then that could also be another data point. Based on all this, you can again do a segmentation of saying that here is one cluster of employees that left because of low salary, right? I mean, that's one cluster, right? You can again say that here's another cluster of employees that maybe quit because of, they had their personal reasons or they want to pursue higher education, whatever, right? So you just have to look at the data and see how, does it make sense for you to apply clustering, right? In that context. So the context is very crucial.
Yes, sir. Thank you, sir.
Ma'am, actually, we have done here is K-means clustering. Okay, so we have two types of clustering. One is hierarchical clustering and another one is K-means clustering. So let's take your HR scenario itself where you want to analyze the employee attrition rate based on their years of experience. Okay, you want to cluster those employees. In such case, you can go for K-means clustering. Where you are already predefining the cluster and then you are categorizing the employees. And based on that, you can go for your strategic decisions. Okay, maybe even if the employee's experience is good and they have experience more than 25 years with your company, but still they will not be having a good relationship with your company. Okay, so it depends. Then another type of clustering is hierarchical clustering, where we are already, we are telling Python code to determine the cluster size. Okay, so depending on your research or business scenario, you can go for any clustering method. And this recency, frequency, and monetary thing we have done for understand the purchase behavior of customers. Okay, so I would like to show you the output file also, which we got from the Python code. So here you can see the output value. We have customer ID here, then frequency, then monetary value, and also see the cluster count along with the description or label. For example, if you can see one comment or label here, cluster 2 means regular good customers. That means we have to grow them. So they are giving suggestion also based on each cluster, like how you can improve your marketing strategies. Okay, that is the purpose of recency, frequency, and monitoring algorithm. Okay. Shall we move on to the next one? Any doubts in this recency, frequency, monetary algorithm?
Please mute yourself or we will mute all. Yeah, you can carry on.
Anu, I think you've been muted, Anu, if you're speaking.
Yeah. Okay. So shall we move on to the next scenario? Yeah. Am I audible?
Yes.
Yeah. So I hope you don't have any queries on recency, frequency, and monetary algorithm. Shall we move on to the next scenario? Okay. So Vinod sir was telling about like imagine if you want to analyze student performance pattern, okay, and how to devise our teaching intervention. So let's write a code on Python to understand how the student performance can be analyzed or how we can cluster them. Okay. So here also I've shared you the data set. So it's a student data set which include attendance rate percentage, their assignment scores, exam performance, then library resource usage, online platform engagement, and previous semester CGPA. Okay. So the
Are we still seeing the old data set only, Anu?
Is it so?
Yeah. We're still seeing the RFM labels and
No,
all
actually,
that.
you share your entire screen, Professor. Yeah, now it is okay.
Yeah. Okay. So here we are going to see exploratory data analysis, data standardization. Then we are going to identify K, cluster profiles, and also mean values per clusters. Okay. So based on this cluster, we'll be understanding or we'll have a learning on high achievers, struggling but trying group or clusters, then inconsistent performance and at-risk students. So that is aim here. Okay. So I've also shared this Colab file also. So just copy and paste the code in one cell in Google Colab and just press on this play like button, which is a run button in Google Colab. So just click on it. So the coding will be running now. And here also you have to upload the file. Okay. So the file name is synthetic_student_data. The file is available in the Google folder. You can use it. Okay. Yeah. So the analysis has been done. So let's see the output first. Okay. So according to this code, we have used two libraries. Okay. One is Pandas, then NumPy. This is the most important library. Then we have used another library also, which is known as Scikit-learn. Okay. So the main purpose of Scikit-learn is for pre-processing files. Okay. Then cluster import k-means files. Then also it will help us to plot the file using matplotlib library. Okay. So we have used four libraries here. One is Pandas. Okay. Then we are going for NumPy. Then we are going for sklearn or Scikit-learn. And finally, matplotlib for data visualization. Okay. The first step is file upload. So we have uploaded the data. Then we have to read the file. Okay. So using read_excel function, we are reading the file. Then we are going for exploratory data analysis. Then we are selecting features and standardizing the features. Okay. So according to this data set, we have few variables like attendance, assignment average, exam, then
Anu, are you showing a different screen, Anu? Because what we are seeing is your output screen.
Yeah. It's okay, sir. I'm just giving
okay,
overview. Then I'm going to explain the output.
Sure.
Okay. Then after that, we are going for a k-means clustering. Okay. So what is the purpose of k-means clustering? Where we are clustering our students based on their performance. Okay. So we have our CGPA, our students CGPA from last trimester also. So in this code I've given k value is equal to 4. So in k-means clustering, we have to give the input. Okay. Imagine if you want to cluster your students like into 5 or 6 groups, then you can give k value as 5 or 6. But according to the code, if you see means I've given k value as 4. Okay. So that means I need only 4 clusters here. Okay. So once the k-means clustering is done, it will give us a scatter plot as well as you can see a radar chart like diagram also. Okay. So what happens here? So here we can see that they have 4 clusters, right? So when you look at this diagram, we can see that cluster 2 are the high achiever students. That is around 70 students. So when you look at their attendance is around 94%. And when you go for the performance, they are top tier performance. Okay. So their GPA is around 3.54. And their engagement is very high. That means their library hours is around 13
Scroll it little down, Professor. We are unable to see. You are showing the radar chart, right? Could you scroll it a little down, or you download the output and show it is a little small?
Yeah, output is already downloaded. I'll show that one also. Give me a minute.
I think while Anu brings this up, what's on a very on a lighter side of things, right? I am sure your gut instinct of the students, right, will match
Yeah.
what the data says, and that experience and wisdom that each of you have is something that cannot be captured in, in the algorithm.
I think my system got stuck. Give me a minute.
Okay.
In the meantime, somebody has asked whether recency frequency monitoring can be done with HR. I don't know which professor it is. Are you here, madam? Yeah.
So that query is already addressed, sir.
Yeah. No, it can be done in a different way.
Yeah. We told her. Yeah. So this is the output, okay, you get from that Python coding where we have clustered the students into 4 clusters, okay. So if you look at this, you can see that we have 4 clusters here. So let's look at cluster 2 here, okay, because that's what I was talking about here. So what happens with cluster 2 is they are the high achievers, okay. So according to this data set, we have 70 students. So when you look at their attendance percentage, it is 94%. That is excellent. Okay, and their performance is top tier, and exam average is around 89.6 and GPA is around 3.54. Okay, and when you take their engagement also, you can see their engagement is very high. Their library hours is around 13 hours per month. Then their logins are around 10 per week. And if you look at their behavior pattern, they are consistent, self-motivated, and resourceful students. Okay, so what is the intervention here? We have to offer enrichment opportunities to them. Like we have to honor them with more projects, honor projects, or you have to give them leadership roles or mentorship, or use them as peer mentors for struggling students, or keep them challenged, right, to sustain the motivation. So that are the few interventions or interpretations from this cluster. Okay, now let's move on to cluster 1. So if you look at cluster 1, we can see that they are struggling. Okay, but they are again trying. Okay, since I filtered it, only cluster 2 is coming. So let me remove the filter and show you cluster 1 now. Okay, so you can see that struggling but trying students, right? That means their attendance percentage is around 86%, which is very good, and performance is decent. That means their exam average is around 73.7, GPA is approximately 3. Okay, so when you look at their engagement thing, they use moderate use of resources, okay? That means 6.6 library hours, 5.6 logins, okay? And if you look at their behavior pattern, they are committed learners, right? Who are putting in effort, but may need help with deeper understanding or exam preparation, okay? So what will be your intervention for this cluster? Can anyone just tell or give a chance of how you will be doing intervention for this cluster? So you understood, right? They're struggling but trying students. So what will be your intervention for this cluster?
Yes. Someone has said mentoring. Yeah.
Mentoring, okay. Oh, very good. Okay, so it depends. Yeah, very good. So what happens is depends with the professors also. So if I am in that case, in that case or scenario, means what I'll do is I'll provide structured academic support for them. So in the form of tutoring or feedback loops, okay, emphasize study skills and exam techniques, or I may use adaptive learning tools to target weak areas. Okay, so that's the approach I will take for this cluster. Now let's move on to the next cluster, which is cluster 0, the next highest. Okay, so when you look at cluster 0, we can see that their performance is inconsistent. Okay, so we have around 76 students, approximately 25% of the entire population. So attendance is around 69%, that is average. Engagement is low to moderate, which is around 3.7 hours library and 3.7 logins. Okay. So if you look at behavior pattern, they are sometimes engaged, sometimes disengaged, and their performance also fluctuate. Okay. So what kind of intervention we can do for this cluster? So they are like, what to say, inconsistent performers. So what will you do with this cluster? Or they are at risk students, okay? Okay, so in this case, what we can do is we can go for an introduction of an attendance tracking and motivation nudges. Or being a professor, we can give personalized feedback to all the students and help them having a goal setting plan. Another thing is what we can do is we can help them find consistency through time management workshop. Okay, that are the few interventions for this cluster. Now let's move on to the last cluster, that is cluster 3, where we can see, okay, a group of inconsistent performance. Okay, so what happens here? You can see that they introduce what to see. The attendance percentage is around 69%. Okay, so if you look at their performance, it is very uneven. Okay, so what happens here? You have to help them, right? You have to give them an early warning system or a counseling referral, or you can give some extra remedial learning plans to them. Okay, extra coaching or emotional support. Okay, something can be done. So what happens is you have to simplify digital platforms or offer low barrier entry tasks to re-engage. Okay. So from this clusters, we have a distribution summary like we have struggling but trying. Okay. Then inconsistent performers, then high achievers and at-risk students. Okay. So together, these clusters give a 360-degree view of our student population. Okay. So about 2/3 are doing okay to great, that is cluster 1 and 2. And when you look at cluster, the remaining cluster, that is cluster 0 and 3, they are 1/3 of the student population. Okay, so you need to give, or you have to have more need behavioral or academic intervention for these students. Okay,
Right.
so you should arrange these students, or you should cluster them based on their learner group. And based on that, you have to give, frame your academic focus or support strategy or whatever interventions you want to implement with them. So you have to focus on the cluster segments and do it. Okay. So this clustering gives a data-driven guidance for targeted resource allocation. And also, instead of one-size-fit-all teaching, intervention
Exactly.
can now be personalized. Okay. So based on the clusters, we can have personalized interventions. Okay.
In fact, Anu, if I was to add, right,
Yeah.
what would, so as Anu mentioned, there's 500 students, right? It would be impossible to create interventions for 500 students.
Exactly.
Now, what this does is break this down into manageable chunks. And those manageable chunks are very, very data oriented, right? So there is data that backs up why you have included a student in a particular group. Now, the question on HR that someone asked about, typically in most organizations, the HR performance is also done on similar parameters, right? You have, high performers, you have above average, then average and low performers, right? Based on business and the parameters are similar, right? You would rate on task, you would rate on tenure, so on and so forth, right? You have a set of parameters on the top similar to what you have here. Now, for performance rating, similar to what we spoke about in terms of coaching, counseling, and others, for the high performers, you would have interventions that would sort of take them on to the next level. You want them to continue performing. So you would provide additional training um, resources to them, right? You would provide maybe additional incentive also, right? Monetary. For the ones that are above average, you want to push them to get to the high performance zone, right? So similarly, your intervention strategy will be based on where these employees are. So clustering really helps. A lot of us, like I said earlier on, we naturally form patterns. We naturally form clusters. And, the K-means and other clustering techniques is really a validation of our thought process. I just wanted to add that, Anu, to your excellent examples that you showcased.
And to run these practice experiments and come back to us if you have any doubts. So we saw two scenarios now, like one was on customer segmentation, that is RFM style plus rule-based mapping, okay, to 5 named segments. And another one was on student performance, okay. So kindly run the code. So based on the scenario only, you have to choose the right analysis. So whenever you have a big data with you or a big population with you, and whenever you want to analyze the crowd, whoever it is, whether it's a customer or just one ma'am asked about an HR or even students, whoever it is, when you want to cluster a crowd and understand their behavior, then K-means clustering will be the right analysis. Okay. Any other questions?
Okay, I think we can close the session, Professor Anu.
Okay, sir.
Thank you very much, Dr. Venut. You have done a very excellent job, sir. Your presentation was very good, and it was added value to how Anu is clustered. Very practically, she has explained. So you both, the two sides of the coin today, did it very perfect.
Thank you, sir.
It is always a pleasure to collaborate with you, Anu and Murali. I really hope everyone who participated and attended found this valuable. You can always reach out for any additional questions. There is enough and more material available in the public domain for you to experiment and innovate on some of this by yourself. Yeah. Thanks again. Have a good evening and a good rest of the week.
Thank you, sir. Thank you. And for participants, for your kind information, now I'll share you a QR code where you can scan it and you can keep the attendance, or you can take a photograph and fill it within 15 minutes. So the name will be in the drop-down box. You no need to fill it out like how the 3 days has been. Hope you can see my screen. Just a minute. Please scan it and fill it very perfectly.
Yeah, sir. The screen is visible now.
Yeah. And please don't select the
Dear
wrong.
participants, kindly scan the QR code and fill the attendance form. Please choose your name alone. Please don't fill for others. So we request everyone to fill for your name alone. So the names are available in the drop-down list. So kindly choose your name and fill the form.
And those who had an issue, you please stay on the line now itself. We will mitigate it lively. Okay. For more than 20 people we got mitigated. Only very few are there. That's all because of the name mismatch in the Google form and your actual name. So those who have an attendance issue, you can talk, sir. Just give your name. We will finish it lively. Then and there you can leave. This is the last chance. From tomorrow onwards, no requests through WhatsApp or email. It is very tough to monitor because, we were actually, just a minute. Actually, we are having 400 plus participants through registration, but only 250 are attending. So we need to omit all those 180 participants, and we need to give importance. So we are discussing this much. Yeah.
Murali sir, sorry to interrupt. They are not able to fill the form.
Is it?
Yeah. There are few comments like when they scan, they have been redirected to some other page.
Just a minute. No, it will go to other page only, but you have to select continue. There is a button called continue. You have to select that. Just a minute. Let me go out.
Following domain most commonly used domain.com.
No, madam, if you click that.
Who is associated with each of the following companies? Google.
Just a minute, madam. I'm just putting it. Please wait. It will take you the QR website.
Please wait. Dear participants, please wait.
Just a minute. Just a minute.
Bombay Stock Exchange, sorry.
No, madam. That is an advertisement. If you scroll down, there is a button called Watch to continue. I mean,
sir, it is asking for a access. Like it is saying that you have to request.
No.
Give the attendance, sir. No, sir. As you said that, I am also doing the same thing what you said, but we could not be able to mark the attendance, sir.
It is saying request access, so we have
to give access in Google. They are not
Actually, you need to change. Sir, actually, you need to change in the form itself, sir. When you created the link, there will be.
Just a minute, madam. I can understand. Please wait.
Sir, can it be a bit faster? Actually, we need to go somewhere. Actually, it is 9:35 already.
Sure, sir. Sure, sir. Give me just one minute, okay? We'll share the link.
Sir, humble request, kindly share the link.
Yes.
Because those who are joining with the mobile phone, how they can scan?
ಇದ್ರಲ್ಲಿ ನನಗೆ ಏನು ಗೊತ್ತಾಗ್ತಿಲ್ಲ ಯಾಕೆ ಹಿಂಗ್ ಆಗ್ತೈತೆ ಅಂತಾನೆ ಗೊತ್ತಾಗ್ತಿಲ್ಲ.
Okay, just made anyone. Now you can refresh and you can see. Okay.
If anyone can share the link on this chat box.
Sir, at least share the QR code in the WhatsApp group, no?
Sir, it is opening, sir. Now we could able to mark the attendance.
Sir, can you share the QR? Can you show the QR code again?
It is opening now. Thank you.
Sir, please share the QR code in the WhatsApp group.
Where is the earliest question? Bhubaneswar.
What about
The canal which joins Baltic Sea to North Sea is Kiel Canal. Tennis Open Cup. Operation Cold is launched by which...
The link is also shared in the chat box. Kindly fill the attendance. Participants, kindly fill the... Participants, kindly fill the attendance by 9:45. Those who are not able to scan the QR code, I've shared the link also in chat box.
The attendance issue. Could you please come up in the line now? We will do it.
We could able to mark the attendance by scanning and as well as through the link also, sir. We have marked the attendance.
Thank you.
No issues right now.
Okay, ma'am.
Thank you.
Okay. See, those who are having attendance
Sir,
issues,
I
the
have an
previous
issue.
sessions, kindly
Hello.
stay back.
Sir, this is Sushila Triveni, Vemula Sushila Triveni.
Yes,
I
ma'am.
kept in the WhatsApp also. I
Yeah.
have given the feedback all the 3 days, sir. First
Just a
day you
minute.
shared 2 links,
Madam,
actually.
just a minute,
Yeah,
madam.
sir. Yeah, yeah.
Since
Hello, madam.
you would have gave the names very differently, just post your name here, ma'am. Please post it.
Here in the group?
Yes, in the chat box you post it. Let me clarify online itself. Okay.
Sir, even my name is also not there in that
Just a
drop.
minute, ma'am. We'll see one by one. Okay. Tomorrow it is unable to see in the working hours, ma'am. It is really creating a pressure for all of us. So that we have made it as a drop down from today onwards. Did you post it in the chat box?
Yeah, I shared it, sir.
Just a minute.
Vemula Sushila Triveni. I'm unable to see the message also. I don't know how.
Have you filled the Google form or not, madam?
All the 3 days I felt, sir. Today I'm on the job only.
Did you fill the very
Vemula
different
Sushila.
name?
Vemula Sushila Triveni, sir. My name.
But how you filled or registered in the Atal, madam? Is it different?
Yeah, because it has come into my mail ID only. In that only I'm filling.
Hello, sir. Hello. Hello.
First day I filled 2 forms because 2 times you shared. Second and third day you have given 1 link only.
Hello, madam.
Hello.
Hello. Hi, madam. Which one is correct, madam? QR code or Google form link? Hello. Hello. Hello.
Sir, you can fill it in both also, sir. Both are working.
Now, which one
You
is
try with the link. You try with
how
the
to
links. The
fill?
link is also working.
Google link or QR code?
Sir, both are working, sir. You can try in both.
Yes,
Anyone
both
is
are
okay?
working.
No, anyone is
Yes.
fine, na, madam?
Where we will yes, sir. We are comfortable.
Murli sir, I have dropped a message on the chat
Sir,
box.
here it is as Dr. V.S. Triveni in your roles.
Yeah, those who don't have any attendance issue can leave, okay? We'll meet again tomorrow in the...
Yeah, actually I gave it as Vemula Sushila Triveni. And here it is, you mentioned in the box, it is Dr. V.S. Triveni.
Where we will find the scan code?
I too have an issue because the name has an initial miss, and as per my registration, it was Dr. Vipa Dhingra. So I've dropped the message on the chat box also, and from last 3 days, I am filling by my correct name, that is Doctor with initial, because that would reflect into a certificate if you could correct.
No, certificate and all, it is based on your Atal only, ma'am. So what I will do is, I'm just sharing one editable document now. Okay. I'm just putting it in the Atal FTP. Okay. There is something called a missed attendance. Can you see that? Yeah.
Where, sir? In the group? In the chat
In the
box you are
WhatsApp.
saying?
No, the chat box is not good to post anything. I have posted in the WhatsApp group. Okay.
Okay, sir. Okay, sir. I'll just check.
Just you type your name in a serial number order, ma'am. That's all. Okay. I will
Sir,
rectify.
but in that group, na, only admins can send message, sir. Morning I noticed.
No, madam, I'm not asking you to type message. You can open that and you
Okay,
can,
direct.
it's
Yeah.
a sheet.
Yes, I understood.
Just
Good
type your
Yeah,
full
sure.
name as per your, from tomorrow onwards, this issue will not be there because we collected through.
Good evening, sir.
Dr.
Sir, I'm
Yeah.
Subhashri. My name is not there in the Google form, sir.
Madam, that is what I am saying. Who madam? Today.
Today only. That is, you have just given that list, no, sir? Name.
Yes.
Name
Yes.
list. In that,
Yes.
my name is missing, sir.
That is the full participant list. We have 429 members, ma'am. Definitely you would have.
Ma'am, how did you fill your name in registration form? Whether
Ma'am,
it was
Dr.
Dr.
R.
Subhashri
Subhashri
or
only.
Miss
Last. Sorry, ma'am. Please tell me, ma'am.
whether it is Miss or Mrs. or Doctor.
No,
Could you
ma'am. I've
please
just typed as a Dr. R. Subhashri in the last 2 days attendance list. I've typed
No,
only as a
ma'am.
Dr.
When you
R. Subhashri.
register in Atal portal, how you register?
There also Dr. R. Subhashri only, ma'am.
There
Could
is
you
something
please
called Mrs. Subhashri in 415. That is what the
No,
records we have.
that is not my name. Why? Because just on the first day I've just splitted the group. No, in that name
Yes.
also I got the correct name. I got correct name. Dr. R. Subhashri only I got.
This is what we had, madam. Just a minute. Let me check and tell you. Okay.
That what I just checked, sir. My name is not there.
give me 1 minute, ma'am. Sir,
Okay, ma'am. Okay.
Give your full name.
SUBHASRI, sir.
Fill that Google sheet what you shared by opening the link in the WhatsApp, but I'm unable to enter my name.
Yes, sir. Actually, it is not, it is view only. It should be written, na? It is showing that link view only.
Madam,
sir.
it is there, madam. Dr. R. Subhashri, serial number 43. It is there. Please see.
Sorry, sir.
Sir,
I'll check
my
once
name
again.
is
Thank you,
also
sir.
missing, sir.
Thank you, sir.
Your name?
Sir, my name is Shanu Priya, sir.
Shanmu Priya, number 331. It is there, madam.
Check
I mean,
it, sir.
it is there below. It is there. Dr. V. Shanmu Priya. It is there. Please check.
Okay, sir. I'll check it, sir.
Sir, here in the WhatsApp link which you shared it, we are unable to type it, sir.
You can type. People are typing here. Just a minute.
No.
Please refresh it and see. I gave access long back.
Not coming. Not
Refresh,
opening.
madam, again, please.
It is view only, it is showing, sir.
No, madam. Now you can edit. Please see. Type it and see,
Yeah.
madam.
Sir, where we will find the scan code?
Scan code is here, sir. Please scan it.
Where?
Where are you, sir, all this time? You have posted very long back.
No, sir. We are not able to scan it. Where
Please.
I will, the chat box is not there.
Please scan it, sir. It is here. You can scan from your QR scanning app or anything.
Thank you.
Okay. Take a
Murli
photo.
sir,
Yes, ma'am.
if the initial is incorrect, Miss and Doctor, so should I write it into attendance list or something?
No, madam. You just give your name alone in that link.
No, sir.
Let me clarify.
The point is, if the initial is incorrect, like even in my name, it's right Dr. Gayatri Panda, but it is Mrs. Gayatri Panda. So, sir,
No, madam. That is not given by us. That is actually we got from Atal portal only.
Sir, I got it your point. But when we registered, maybe it so happened that we were not awarded our PS. So we registered long back. And so what can be done, sir? That's why we are.
You can do, madam. You can edit it in your profile. You can log in and edit it, madam.
Okay, so if we do update the things, so when we
I don't aware about it, madam. I think it should be updated before the generation of certificate. You edit it now itself, madam. Yeah.
Okay.
Okay. Have you all filled it?
Yeah, it's done, sir. We have done it. We filled it. Vemula Sushila Triveni. Actually, in the form, in the today's form.
Yeah. I can see.
It's like Dr. V.S. Triveni.
That I will see, ma'am. From today onwards, there will not be this issue. Okay. Only 3 have they
Yeah.
filled.
All the 3 days I submitted the feedback.
Let me
sir.
check it, ma'am. Let me check it. We have a clear record.
Yeah, please. Yeah, it's in the
Okay,
name
sir.
of
Thank
Vemula
you, sir. I'm
Sushila Triveni.
Subhashri. Thank you so much, sir.
Thank you very much.
Thank you, sir.
Hello, sir.
Yes, madam.
Yeah.
Sir, this is Kusum.
Shall I leave, sir?
Please leave, madam. Yeah.
Sir, I scanned the QR code,
Okay.
but I think so. I don't know because I have an iOS, like I have an iPhone. I'm unable
Okay.
to open the Google Sheet. It's not, but I have marked my attendance through the link which you have sent. It's fine, sir.
Oh, fine. Both are same. Yeah.
Okay. Thank you so much, sir. Thank you,
Okay.
sir. Yeah, good night, sir. Yeah, thank you.
Okay. So only 5 have rectified. Okay, I think others they have or not, I don't know. So thank you. I'm leaving. Those who have attendance issue, please finish now itself.